And initiative is, well, I talk with Phil, I think, here, isn't it? To approach a little bit University of São Paulo. So that's the whole goal here. With the links, especially France, US. So this initiative is to show what we have here with the university, the 3 universities, and with Inria, and to get more active for forces, more collaborations. And it's really a pleasure to have almost all the rector couldn't be here. He's in the interior in an event, but we have 4 provosts here, and 3 actually. So I would like to thank Professor Luizio, that's provost for graduate students, Professor Marli, that's for culture and extension, Professor Paulo, that's the provost for research, and I will join compose just the open ceremony here very quick so we can get to work. Yeah, I invite Cécile to compose I want to thank my counterpart, Pierre Alexander, also for the organization of this from the French side. So without him, this will be impossible. And I want to thank all the speakers, all the visits that are going to do here in the university. You want to say something? Just a few words before I compose the open ceremony?
So thank you very much. Good morning, everybody. So I have to say something, because if I don't say it, who will? So thank you very much, Sergio, for your huge work for this organization. Without you, really, would have been impossible. Not only from the material side of the preparation of the event. So really, thank you very much for your patience and so on. Thank you very much.
So before the open ceremony, since we don't fit on the table, I want to call Nadej from the consulate side, say some words and welcome.
Thank you, Sergio. Good morning to everyone. I am really happy to be here with you today and tomorrow too. Just words, you all know digital transformation of the science, the economy and the society is now and is our future too. So it's really important, the research, and not only research, but evidently the question of collaboration on these topics, the topics of digital transformation. And Inria is an organism, a research organism, a research institution in France, who was really pioneer in this question of digital innovation and research. And since the beginning, it's really interesting, since the beginning in the 1960s, Inria was making bridge between the academic world and industry. And today, it's what we want to do, and Inria was doing it in the 60s. And it's interesting to see Inria today in this old dynamics USP has with France, Pasteur, as Sergio said, CNRS, but it's not only USP, I wanted to say, it's all the states of São Paulo today, it's UNESP, it's Unicamp, and all the universities to make and to do a collaboration with Inria. So full event. I hope a new collaboration will emerge of this workshop. Thank you.
Thank you, Nadej. So for the open ceremony, for a few words, so I want to invite Cecile now without delay. Sorry for getting you up and down. You want to have a seat, just very quick? Yeah. I want to invite Professor Sérgio Proença from the counterpart from USP. That's the international agency. Representing the rector, I would like to invite Professor Paulo, if you want, to compose the open ceremony. And from FAPESP, we represent FAPESP, Professor Fernando Menezes. Will just a very quick words for the opening. I think is very important. I want to thank the presence of the other provosts. Thank you, Professor Catalani from the Innovation Agency and all the authority here that led us to have you all here. So you have the word. I don't know if Professor Sérgio Proença will start. Which one? The host?
I think as a host, I can say the final words.
Good morning, everyone. My pleasure to be here. First of all, I would like to thank Professor Sérgio for carrying out the challenge to organize the meeting and workshop in order to show up to Inria abilities to at USP in terms of research, for instance. Into biotechnology, chemistry, so all the tools relate to having many fields to explore. To quite interesting. We know that already have very good link, but it's time to more. And I would like to say this is in line with recently partnership with France, and then having a Congas. So I would like to congratulate you, Sergio. I hope that next 2 days we are going to fruitful work and discussions. Let's see. Great.
Thank you, Sergio, for the invitation. Pleasure to be here. I as a university law school, but now representing the São Paulo Research Foundation. So I'm here representing the São Paulo Research Foundation, FAPESP, as its administrative director. And in the same way Sergio just said, we are in a special moment. Our institutions, University of São Paulo, FAPESP, and our other institutions from the science and technology environment of the state of São Paulo concerning partnerships with France. We are just arriving. We three in this on this table, but we three were just arriving from France 2 weeks ago. A very strong program on cooperation in several areas. Very fruitful week discussing partnership. And of course, today, tomorrow, and everything we are continuously building with Inria is a very important element on this universe of the French-Brazilian cooperation. You know about FAPESP. I think I would not need now to say special details of our way of working, but I know during these discussions, especially tomorrow, there will be a special panel on tools for cooperation. And we have here at this very institute people, especially Fabio, who know perfectly well the way of FAPESP acting as strong advisors in our scientific directorate. So for this opening ceremony, just my thanks again, Sergio, and my strong belief that we'll continuously increase our very important cooperation. Thanks.
So I'm Cécile Vigou, and I am the Director of International Relations at Inria. So Fabien, Nadej already said a few words about Inria during our presentation. So Inria is dedicated to apply mathematics and computer science, and we are a national institute, meaning that we are currently located in 9 different areas all over France. Come back to that later because it's going to play a part in the collaboration that we are going to develop. So first of all, I want to thank USP for hosting us today because it's our first live, so to speak, workshop within the Inria Brazil program. We had a workshop last year, but online, because this, of course, there have been a lot of collaboration between Inria and Brazil, but to have an institutional structure for this collaboration started only in 2020, January 2020, just right before COVID pandemic. So of course, everything was put on hold. So that's why I'm very happy that we can be here today and with such quite a few, not a few, but quite a huge amount of representatives for Inria that traveled to Brazil. Secondly, I want to thank Sergio and Pierre-Alexandre for putting up this event because it's the first time we are having this event in USP. So it took, I know it took a lot of work to be able to have it today. So thank you to because the program is going to be a very rich program focusing on scientific collaboration, of course, but also, as it was mentioned before, tomorrow on cooperation tools in order to increase this collaboration, but also innovation aspect of the collaboration and how we can develop and strengthen this collaboration. So these 2 days are going to be, hopefully, a way to have a lot of exchanges. And thirdly, I want to thank you, the 4 provosts that are here today because it shows your interest for the collaboration. So we are really honored and delighted at Inria that you took the time to be with us this morning. And I hope we will be able to exchange and to see in which path we can go. So Inria Brazil is a collaboration that is focusing on 4 main topics: high-performance computing, artificial intelligence, scientific computing, and data science. But of course, it's not limited to these first topics. And not only we are applying these topics to a lot of more applied fields like energy, health, biology, for example, but we want also to focus on topics that are of interest for the universities. And for example, during the workshop within these 2 days, there will be a strong focus on mathematical epidemiology because it's an important topic at Inria, and we know that it's also an important topic here at USP. And I'm saying USP, but of course UNESP and all the other universities, we mentioned Campinas before, that are going to take part of this workshop today. So we have ongoing collaboration. Pierre-Alexandre Bliman has a lot of collaboration, but somewhere in the room, Mustafa Adimi, over there, is also having ongoing collaboration. So we are not starting from scratch, of course, and we never start from scratch at Inria. Every time we build collaboration and partnerships, we start from bottom-up activities from our researchers. And we have a strategy at Inria that is to focus on a selected, limited number of international partnerships. And Inria Brazil, so I'm sorry, I'm saying it in English. I know my colleagues are saying it with the Brasil, thank you. But I don't speak Portuguese. So, but for us, Inria Brazil is really a powerful tool for Inria and for France to develop collaboration with Brazil. So we really hope to increase all these collaborations. And then I think I said everything I wanted to say. So I want also to thank the 2 persons that have been of major importance to build this collaboration. Patrick Vaduriez here, that is the scientific director for Inria, and somewhere in the room, Frédéric Valentin, over there, that is working in LNCC, because thanks to them, we've been able to have this strong connection, and our idea now is to have a network and with a strong focus in São Paulo area. I thank you very much, and I think that's all I had to say. Thank you.
Bonjour, bienvenue et tous à l'Université de São Paulo. Il fallait dire quelques mots en français pour vraiment vous accueillir ici. Now I switch to the universal language of science, broken English, to say it's an honor to host this workshop here. I would like to congratulate the organizers. I'd like to congratulate Sérgio Oliva. I would like to congratulate my co-host here, Cecile, Sérgio Proença, Fernando Menezes, and in the name of Marli, to say hello to all the authorities in the room. So it's always a responsibility to represent the president of our university, Professor Carlotti. And one of the first things I have to say is that people keep forgetting that he gave me an important task, not only to be provost for research, but for research and innovation as well. We incorporated innovation in our office last May. We have 2 deputy provosts, one for research and one for innovation, and they're both in this room showing how valuable this event is. As Professor Fernando mentioned, we have extremely strong ties with France. Our university has very strong ties with France since our foundation. But in these recent years, I think most likely thanks to the wonderful, energetic and competent personality of Nadège, we've really strengthened these ties. And we spent a fabulous week in France talking about just a few of the collaborations that we can have with France. The topic here is of utmost importance, and it's also very important that this is not strictly an event of Inria and the University of São Paulo, although all of us on the Brazilian side here on this table are from the University of São Paulo. Fernando has the FAPESP hat, but he's also a professor at the University of São Paulo. Right now, high-performance computing was mentioned. There's an opening, there's a call for a center for high-performance computing in the state of São Paulo, and this call is being dealt with by all universities, not only the state universities in the state of São Paulo, but all universities are putting together a proposal to have one center that will be used by everybody in the state of São Paulo. So this spirit of bringing together the community is right, on our agenda right now. Second observation, scientific computing, as already mentioned, this is a topic of utmost importance in our university. We have 2 computer science, very important computer science departments here and in São Carlos. We are very much into that. I would like to make just a few comments on the other 2 aspects of Inria to show how important and how broad this whole subject, this whole field is. Data science and artificial intelligence. Just this morning, I signed a petition to halt further development on artificial intelligence going beyond GPT-4, so that all sorts of ethical issues, all sorts of legal issues can be looked into with a little more detail and not, rush ahead without taking into concern ethical and responsible research and innovation aspects, which is of utmost importance. Society has to know what is going on to be able to make informed decisions. The other point I wanted to make is about data science. Now, obviously, we are overwhelmed with data these days, and we need ways of treating these massive amounts of data. But we shouldn't forget some warnings, such as a warning given by Frenchman Henri Poincaré in his La science et l'hypothèse, where he says, science is made, we do science with facts, with data. But just an amount of data is no more a science than a pile of bricks is a house. So we need to make sense out of the data, and that's a job which requires fine-tuning, which requires very careful analysis by everybody in this room. So with that, you know, given that the subject is so important these days, that the aspects are so broad, I really am happy to see this workshop happening here, and I welcome you all to enjoy these 2 days. Thank you.
So with that, I want to thank all the speakers, and I think we are on time. It's incredible. And we can just take a few moments to close the opening sections. And just for the ones that ask us, the Wi-Fi, it's on the board, because we thought that everyone has EduRoam, but it's not that the case. But and so we can start for the first lecture, this opening lecture, that Professor Fabio Cozman will get. This artificial intelligence was mentioned everywhere, so we thought that would be nice to start with him, and thank you for that. Just one comment, this section that's more of the connection between USP and Inria is being broadcast, so if someone is not comfortable with the broadcast, please tell us, then we will turn off the broadcast. So it's, if Professor Fabio it's agreed to broadcast it, so it's being broadcasted. Pode pôr na mesa. Assim. Okay. Oh, Patrick. Okay. Please, just a few words while we are installing it.
Bom dia a todos. So just a few words. So I'm Patrick Valduriez, I'm from Inria. I'm really happy to be here because I've been working with Brazil for more than 30 years. So my first PhD student who came at Inria from Brazil was in 1991, Rosana Lancelot from PUC, Rio. So it's been a long way to arrive here. And I think the message I want, and I'm sure Frédéric will agree with me. The message is also for the researchers from France and Brazil. It's not a problem. We know how to work together. We can work very well. We have success stories. I will give a talk after tomorrow on data science, which is my field, and innovation. We have real good success stories at Inria Brazil. What the message is more for the authorities who have helped us, so Inria and so on. And it's really the right time to give us sustained funding. What we really don't like as researchers is, one-shot funding. Here's a big program. Everything will be solved, and 2 years later, nothing. And then it doesn't work this way. Poincaré was mentioned. We need to really think AI. A lot of issues right now. We need really to have funding to do great work. So I hope there are the right people here that you will continue to help us. I think this is the right time, and I just want to thank you all. And maybe a few words from my colleague from LNCC, and maybe you want to say something about the workshop in LNCC, because it's a 1 week in Inria Brazil. Because Inria Brazil is not only São Paulo, very big of course, but it's also Rio de Janeiro and other cities.
Bonjour, good morning, and so it's my real pleasure to be here as a LNCC representative, actually. So let me just say some words about my connection with France and Inria. So I'm French at the beginning, and but I moved here when I was 2 years old, so I'm Brazilian. But after that, I went to France at Inria, where I did my PhD. And then I came back, and I did all my studies here, and now I'm at LNCC. So it's really a real pleasure to be part of this new collaboration that will move on a next level in it. So LNCC, as a national laboratory, is welcome you to bring cooperations in Brazil all over the places. We want really to be like a hub of Inria and the other partners in Brazil, as a national laboratory should be. So thank you very much for being here, and I hope to see you, everybody, at LNCC in 2 days from now. I know that is not so close to here, but it's just a 1 hour flight, so thank you very much.
Thank you, Fabio. I think this connection with LNCC is old, and with universities, and I think it needs to grow, actually. So, without delay, thank you again, all the participants from this opening section. I will pass to Professor Fabio Cozman.
So, good morning. It's a pleasure to be here. Thanks, the organization, for the invitation. I'll be presenting, maybe in 30 minutes or so, the Center for Artificial Intelligence that we have in connection with FAPESP. So I think that's an example of a collaboration with FAPESP, and also with IBM. It's a company, I guess you know IBM. And so the center is an example of a connection between the university and funding agency and a company. So it brings together research and innovation aspects of our activities. Of course, the University of São Paulo has several artificial intelligence laboratories. It has more than one center. In fact, my colleague here, André, coordinates another center called YARA. Our center is called the Center for Artificial Intelligence, USP, IBM, FAPESP. This is a long name, so we just say C4AI most of the time, just to make it short. I will use that at times. And I will start with some context for how it was created. Artificial intelligence, of course, is in the news today. It's everywhere. Everybody's talking about artificial intelligence. But it's not a new enterprise. It's not a new scientific endeavor. It started maybe 70, 80 years ago, depending on how you count. And the University of São Paulo has had research groups working on AI for decades now. So it's been a really strong place for AI research. And if you think about Brazil, you can look at data. Of course, there's lots of data on AI now. This is some data from FAPESP at the top here. If you count the publications, Brazil is between 10 and 15 place in the world, has been for several years. In 2018, it was 12 in this scale. If you look at data from the OECD, they have AI observatory. They collect data from all over the world. They have data such as that in the right, on the bottom right. So you can see that the countries are ordered by the number of publications, and then per capita income, which is probably not the relevant part now, but you can see that you have United States, China, and then you have a number of leading European countries. France is there. Of course, France has a very strong tradition in AI. Everybody in the field knows that France is a place where knowledge representation has been very strong for decades, in fact. So France is there, and Brazil appears here. So it's been around start of right before the big players. It's been a challenge, but we're there. There's a lot of activity going on in the country. We have a computing society with thousands of members, and we have centers all over the country, as was. We have to remind ourselves that Brazil is not just São Paulo. There's lots of places where we have excellent research. And in São Paulo, of course, there are many ways to count these things. There's one index that was produced by the University of Tsinghua in China, and they counted the number of researchers who have high age index. So they came up with an index, of course, and this Brazil looks good in this index, so that's why I'm showing it. So Brazil appears here. Of course, France is on top. But we have a number of leading researchers, and like I said, quite a few research labs and activity going on for decades. There are several universities. USP, Unicamp, and Unesp are very good places. I think USP is just larger, and so we have had labs for decades in USP. Here at the Institute of Mathematics and Statistics, of course, in São Carlos. São Carlos has a very, very large group of several groups leading related to AI, natural language processing, computer vision for many years. I'm from the engineering school. You can get there if you cross the street. We have had several groups there too. So there's been a lot of people in USP, so I think that is reflected here, and in that if you look at data from 2018, I think things have changed in the last few years, but that's the data we have now. So USP is kind of larger than the other ones. Unicamp, of course, appears next, and then Unesp right there. So what happens is, a few years ago, it was clear that we had a number of people in USP in several locations working with AI, and we were missing a sort of more connection between these labs. We had a workshop in 2017 at the Institute of Advanced Studies. The university has a institute focused on advanced thinking and forward thinking. That workshop was, it was very well attended. It was the largest workshop ever to have happened by the Institute of Advanced Studies. And then after that, the administration, the central administration, decided to foster these connections. And so in 2018, the university launched a joint project calling for people to apply for grants. And more than 100 groups were identified in that process. And then right after that, FAPESP launched a call for proposals to put together a research center. In this program that FAPESP has, I suppose Fabio will talk about that, I'm not sure, but it's a program for, the name is Research Engineering Centers, not just about engineering. I guess engineering is a term that is there for historical reasons, but it's a program that funds research centers together with companies, right? So you have a company, usually a large company that can afford substantial funding for research, and then FAPESP matches the funding, and the university participates with people, personnel, space. And so we had this call for proposals launched in 2019, specifically calling for centers in artificial intelligence to work with IBM. Okay, so we had a proposal, we put together a proposal, and we were lucky enough to have it approved. And so then we put this center together. It started in 2020. Our mission is to do artificial intelligence research, of course. That's the main thing, is to do research. We want to continue this, this tradition of that we have in doing research, but also we would like to have more impact. I think what happens in Brazil, we have lots of publications still. I mean, you compare to other countries, but perhaps not as much impact as a country like France, for example, who has more tradition in the area. And so we want to do research, but also these centers are also worried about debating the issues, getting the population to understand what's at stake. It was mentioned today already that there are ethical concerns related to AI. concerns related to marketplace. I will say a few words about that. So that's our center. We have a number of physical sites. Our main site, our headquarters, is at a building nearby. This building belongs to the IME-USP facility, which was run by Professor Catalani. We were lucky enough to have him supporting the whole idea. This was very important at the beginning. And so we have the headquarters there in that building. And then we have a few other spaces, one in São Carlos, which is relatively large, and two smaller ones in Piracicaba and Ribeirão Preto. So this is how it looks, our headquarters looks. You can get there, we're most welcome. You go, if you want to see how it is, let me know. We have some large computational infrastructure that's really necessary today in AI. Just to mention, this picture will not say much, but this is the picture of our cluster. It's a GPU cluster that can run the large models that we have today. It's like more than $1 million thing that we bought with FAPESP money. So thanks, FAPESP. So we have now about 250 people connect to the center in different capacities. We have about 90 faculty members from all over the place. This is one good thing about INOVA-USP is that we can have people from different units of the university collaborating and participating together in projects. We have people from, of course, computer science, engineering. We have also people from the medical schools actually. We have more than one. We have people from the agriculture unit that we have in Piracicaba. And also we have even people from political science, economics, law, discussing exactly the challenge that AI brings to society. We have about 50 students at any given time with scholarships. We have had more than 100 already finished. And then we have about 100 additional students who come with other scholarships and want to participate in the center. So it's like a network with lots of people. We have meetings. You can see the photos there, some of the meetings we have had. I would like to say a word about governance because I think that's interesting. We have 3 committees. One committee is the executive committee. That committee meets every week and sometimes more than once a week. The interesting thing I wanted to point out is that it consists of 4 people. It's myself, I'm the director. Then there's a colleague from São Carlos, who is the guy working with dissemination of knowledge. He's from computer science. There's another colleague of ours from political science. So just to indicate how we try to make things broad. And then there's a person from IBM. Claudio is formally he's a visiting professor, but he's from IBM. He works at IBM. And so this is the way we have a more connection with our partner, and we try to make things align with them and try to get more synergy. And then we have 2 other committees. These are high-level committees. There's one steering committee is like more to discuss strategy from 2 people from USP, 2 people from IBM. And then we have a strategy committee. The strategy committee is the Dario Gil, the director of IBM Research, who is a person from quantum computing. And from our side, by contract, is the provost, Professor Paulo, who's also an authority in quantum, so there must be something there. And then I think representing Professor Paulo is Professor Raul, who is the deputy provost for innovation. So we try to do things in harmony with IBM. That's the goal. We try to get their experience. We try to get some ideas, but we don't do products. We don't do development. We do research, right? So we do research and we show them where we have. We learn from what they can tell us. And then, so we have all these people in the center. Of course, they're doing many different projects. So I will not be able to list all the projects we have. But there are some challenges that we specifically fund. Okay, so these are research projects that are funded by the center using money from FAPESP and from IBM. So we have, let me just go through this quickly. We have activity on language processing. This is very important today in AI. Language processing is one of the hottest topics in AI. Of course, everybody knows about ChatGPT and all that kind of stuff. This is all the hype now. But for us, of course, we're not interested in English. We're much more interested in Portuguese and other Brazilian languages. So we have a project on the processing of Portuguese and another project on the processing of Brazilian indigenous languages. We have more than 270 languages in Brazil, depending on how you count. So we have a project that is related to preserving these languages and giving translators and tools to help preservation. There's a set of projects here which are more like traditional AI projects. There is a machine learning and knowledge engineering for specifically the ocean data. Of course, this is the domain we choose because it's an important domain, but our focus is on the tools. There's another project related to health and specifically happening together with people at the medical school here in São Paulo in Ribeirão Preto. And then there's another project on decision-making, automated decision-making, specifically for agribusiness issues, and actually more specifically about food security and logistics, so that's a concern there. These projects are all led by 2 or 3 people. So in this case, for example, the project on health is led by our colleague José Krieger from the medical school, and Zhao from the philosophy department, but he's from computer science. That's the Philosophy Institute in Ribeirão Preto. And then we have another project, which is in a different color, because I think it's a bit different. This is something that few centers have. I think more and more people are concerned, which is a project related to the impact of technology on society. So these are led by Cristina, who's from the law school, and João Paulo Veiga, which is for political science, is the head of the Department of Political Science. So they are really studying how it is that technology can be regulated, or what are the connections with other sciences, humanities in general. This is happening in connection also with several institutions that are now funded by the federal government to build an observatory, AI observatory. So this is a joint project with many other institutions. Some people may know NIC-BR, which is the institution that regulates the internet in Brazil. They are organizing this. So this is what's going on. Also, let me just 5 more minutes at most. I'll be quick. So we have also activity in outreach. So our concern is not just, our goal is not just to produce research, but also to debate it. So we have a very active YouTube channel, actually. Lots of people go there. We have 2 sets of seminars. If you go to the YouTube channel, you can access them. One of them is in English. It consists of leading researchers giving talks on hot topics. And then there's another series of seminars. It's about really roundtables in Portuguese, dealing with issues that are important to Brazil. For example, we had last year this one on regulating AI. This guy here is the congressman who's in charge of producing a law. But it's not just, we call in Brazil a marco. Well, marco da inteligência artificial is like a set of regulations for AI. So we have had these debates in our center. Last year also we have visitors as well. Last year we had colleagues from the 3ZA from Nice, France. Professor Charles Boveron and Serena Vilata came. Probably my way of saying their names is incorrect. I'm sorry about that. But so they gave talks. It was nice. And Nadej, of course, helped organize everything. Thanks a lot. And then after that, I had the opportunity to get help from the from Nadege and visit 3ZI in Nice. It's good, it's spectacular scenery, good food, and excellent wine, and some science as well. So it was really a complete trip. Yeah, and so I gave a talk to some people there, and Frédéric Precioso was there. I'm sorry, Frédéric, you've seen this twice. Also, we have a few other things happening in the center which are interesting to mention. We have an inclusion and diversity program. So AI, I think all over the world, the AI is not a very diverse area, and this is true also in Brazil. So we have an inclusion and diversity program that is run by our colleagues Renata and Valdinei. Renata is here from the computing department, and Valdinei is from the information science department from another institute. So they run a scholarship program. The students get 12 months and then pass on. We have had some students there. You can see the photos. We got a prize from the city of São Paulo as one particularly interesting program for diversity. We're talking with the provost of inclusion to see whether we can work more closely in the USP Diversa program. So this is happening. Also, we have, I think that's the last thing I want to say, we have also a committee consisting of large Brazilian companies that sit in this committee to discuss the impact of AI, what they suggest to us, and how can we better arrange our research. These meetings happen once every 6 months. In fact, we will have one this coming Thursday, so it's a coincidence that we'll have one this week. And that's what we have. I just put here a few pointers to results of the center. We have produced, sorry about this. We have produced data sets, and also data sets with not just Portuguese, but Brazilian indigenous languages, several languages, in fact. More than 40 languages have been processed. We have had a seminar on democracy and social impact of AI. This is something that I think is relatively rare still in the world, so we're trying to foster that discussion. And also, just to conclude, we have a group working with us, coordinated by Professor Gisele Belgaman from the architecture school. She's an artist, and she's helping us organize an art and AI group. So they explore the connection between technology and art in many ways. So these are the things we've been doing and trying to get this together as being a challenge, but I can only thank FAPESP for funding and for the help, and everyone in the university who's helped, and this relates to many places we depend on, okay? So thanks a lot, and thanks for the attention.
Thank you, Fabio. We have some time for some questions before we can stretch the legs for the next one. So we are open. Professor Paulo.
Fabio, could you go back one slide? I just wanted to, this artificial intelligence, democracy and social impacts, it was a workshop or is it a book? Is there material written up already? So as a member of the steering committee, please send me a copy of that. Thank you. Well, maybe I should moderate other questions.
Yeah, about the number of people working for this center, because you mentioned high numbers of people from faculty and so on. So what's the equivalent of full-time employees, for example?
So we have 4 people working for the center. One is university employee. It's a high-level senior employee who was assigned to the center. And then we also have part-time help from people from different units. Like, for example, the visual identity, all of these is prepared by a person from a different unit, from the physics department, in fact. And then we have secretary and technicians paid by the center. So it's about 5 people to support the center. Not researchers, these are supporting people. I'm not sure, was that the question? Oh, okay, well, that depends. So researchers still belong to their originating units. So I think I'm there all the time, full time. Some people stay there for longer times. For example, João Paulo Veiga, our colleague in the executive committee, is half-time there. Some people just spend a day a week or half a day. Depends on the projects, depending how involved they are. I think we have 90 faculty members related to the center, but maybe I would say 45 of them, half of them, are really working on projects a day a week at least.
Thank you. Anyone else? Chair? No? So just to mention, we do have a visit to Innova. They can get there on site in the afternoon. So thank you again, Fabio, for your presentation. We are ahead of schedule. It's incredible, but we are ahead of schedule. So we have some minutes to stretch our legs. There's some coffee outside, so we can set up here for the next presentation. Thank you.
yes. I'm moving a lot. I'm walking a lot when I'm presenting. So for the people online, if you don't see me but you hear me still, I'm there somewhere. So thank you very much. Thank you for the invitation. So I'm going to present something, very recent results, very recent works that we had. And that we did, so in the Université Côte d'Azur, I am a member of a joint team that we have a lot in France between the University, CNRS, and Inria. So it's the Maasai team. I brought the T-shirt to be perfectly corporate. And so that's 100% of my time is dedicated to this team. Not only this work, this is part of the work I'm doing. And the other 100%, I'm spending them as a program officer or scientific responsible for AI in the French National Research Agency since September 2018. So that means that any research program in AI that has been submitted by colleagues is going to my desk in Paris. So the days are on research and the nights are on the program evaluation. And this work specifically on symbolic and non-symbolic is a joint work with the University of Siena in Italy and Cambridge University in UK. So briefly, yes, briefly, I'm going to introduce the team. So Maasai is 6 permanent researchers from 4 professors. I'm one of them, and 2 associate professors, many PhDs and postdocs, engineers. We have 2 international chairs, with one with Italy, Professor Marco Gori, and one with Canada, University of Laval, and 1 affiliate chair with IBM, just mentioned. And so, as Fabio advertised it very well before, we are on the French Riviera in the Université Côte d'Azur, close to Nice. And the team, the name is coming from Models and Algorithms for Artificial Intelligence. And we are actually a shared part team. Half of the team is statisticians, and the other are computer scientists. So I'm used to present this as statisticians are making explicit statistical learning. They start by saying, okay, the data are distributed among following that law or that distribution. And in computer science, we don't know math enough, so we are doing implicit statistical learning, and we say we leave it to a neural network, a supervector machine, or a random forest to build this statistical model, and at the end, it works better. But oh, I'm online. I should not. And so here you have the different topics that I'm going to present. So since we are a bit ahead of time, I'm going to present for the first hour half of it, and the second hour, no, I'm just be shorter than that. Yes, we have lunch. I know that I'm the last obstacle between us and the lunch, so I'm taking this into account. I'm just going to start by a bit of history, and I was preparing this for the younger ones, but possibly most of you are already experienced this in the past. I see that we are more seniors than juniors, but still, and I'm going to do it in one slide. So I'm doing exactly what I'm advertising my student not to do, putting all the text on one slide. But still, I mean, it's going to be very quick. It's just, if you're young and you don't know the history, go to the Wikipedia page on the history of artificial intelligence. It's very, very informative, in particular of the forces from symbolic to non-symbolic, and explain a lot of the discussion, for example, on ChatGPT that currently is happening. And so in the symbolic AI was the first strongest family of AI techniques that was proposed between the 50s and 95, around 95. But in the meantime, AI has faced two times a winter. First, because of funding cuts in the 70s, mid-70s, mainly because they were not meeting with the expectations on AI. And in particular, and that's going to be part of the talk, that's why I'm making this in the introduction, mainly because in symbolic AI, you make an assumption on how the real world is represented, and that's, of course, not that easy. So if you have a too rigid representation of the world, then the data are not fitting to the detail of the world. And then the second winter came with the high expectation in expert systems like IBM Watson which were again not matching the expectations, but many very interesting ideas and many principles are there. even though has the history of intelligence artificial page will explain you, because it's a fight between symbolic and non-symbolic. For now, the symbolic are lower, are in the shade of non-symbolic. Still, I'm pointing here that many ideas should be considered. And so now that's the non-symbolic era. Since the 95, we can coin it at 95 with supervector machines, random forest, boosting. All these algorithms have been published roughly in that period. And of course, neural networks that were already there, but not making the difference. And in the decades since 95, many reasons made these neural networks neural network models efficient. Often you hear about digital data availability, computer power availability, but many people forget the math contributions. And to point one, I want to point here stochastic gradient descent that made a huge difference in being able to train neural networks. And there are plenty of these. All the colleagues in optimal optimization have been contributing a lot in the machine learning domain. And they are often forgotten in this, hidden in this, when we talk about the emergence of deep networks, but they have been contributing a lot. And of course, as for symbolic AI, non-symbolic AI has a lot of pros and cons. Just to mention that transformers like ChatGPT have no sense of what they are predicting. So that's the reason why there's a lot of interest in the community for moving forward before facing a third winter of AI. And that's not my ideas, of course. I'm on the shoulder of giants, but people like Bernard Skolkoff or Yoshua Benjo are already promoting to move towards system 2 technique, what we have been calling blended AI, that is being able to merge non-symbolic and symbolic AI. So at the top, you have the symbolic AI, you have the data. From this, you extract knowledge. Mainly, Fabio mentioned it also again very well before, with all this knowledge representation progress and all these advances. And then you use this knowledge using reasoning to say that picture here, that data here is actually not, doesn't have the furs of the lion, doesn't have the stripes of the tiger. It's not a big, it's a small one, so it might be a kitten. If you give that image to a neural network that you have trained, and if you don't have given the label kitten for that, but just cat, the network will just predict cat. It has no sense of what a kitten is related to cat. You have a bit of work, people from the symbolic are trying to get back to the top of the wave of non-symbolic AI. So they have been creating neuro-symbolic AI. It was there since the second winter of AI, but there is a lot of effort currently to try to catch up with what has been done in symbolic AI. And so the neuro-symbolic AI is mainly extracting representation from what deep networks are able to do, and then mapping again this symbolic approach. But again, if your symbolic approach is not flexible enough, not large enough, not covering other things, you will miss the point again. That's more or less the And so what we are trying to do is this central technique, which is how can we blend all together these symbolic and non-symbolic techniques. And I will present 3 of the works that are in that direction. We are not solving the problem, and it's going to take 1 or 2 decades, but that's, from our point of view, probably one of the biggest questions in AI in the next 2 decades. And the blended AI term here, the name blended AI is not is on purpose because we have just submitted 2 weeks ago a huge European project named blended AI to do this with plenty of colleagues. And so how to do this, that's what I'm going to present now. But before that, I'm going to explain what we name concept in all these works all together with the colleagues from Siena and Cambridge. So why do you think this image represents an apple? If you ask to a human, it will be an apple because it's round and it's red, possibly. And so how do you represent round and red? How do you store round and red in the computer that you can build a model on top of that? So you can relate round, for example, to different objects that have the same property, so the same shape. Same thing for red. You can look for objects that are associated to the attributes red. And so that you have these objects, then you have the attributes, and what you want is to be able to build the concept out of this, so that then you can start from the apple, say, okay, I'm looking for the concept round, red, so an apple is round and red. And so you can hope if you go through a way to define the objects with their properties, attributes, etc., and match them with other objects which have similarities with the apple, then you may hope that your computer is going to be able to use this. So there's a lot of work that has been done in that direction. And I'm going to present a way that we have proposed to enforce this concept in neural network that was pretty efficient. This is based on some previous work that were made by other colleagues named concept bottleneck models. And so the idea is how to encode the concept so that you get something which is related to the properties of the object, like round, red, squared, cold, and so on. And so based on this concept encoder, then you can label the object as an apple. And of course, you can extract explanation from this model. So that's this explainable AI is for free with this kind of approach. You can think about this, here I'm presenting with an apple, but you can think to any domain that is already having knowledge. So you can put medicine here, you can put biology, you can put cultural heritage. I've been working with these colleagues in plenty of projects. And if you work with a curator in a museum, they have a thesaurus, they have a taxonomy, they have plenty of knowledge that is already there. And you use not at all if you use a CNN to classify the pictures of the object. So you use a neural network, and there is no relation with the knowledge that these people have been building for decades. So this kind of illustration I'm showing here, you can expand it to any domain where you have knowledge, which is more or less any scientific knowledge, and even further. So what people have been doing with these concept bottleneck models, they have said, okay, I have this neural network that is going to extract from the pixels something, and I'm going to force here to get a specific layer where I want to retrieve these properties like long beak, long tail, white chest, black wings, and so on. And so here you put all the concepts that you expect or you hope to find in the dataset of pictures. And then you have a label predictor that can be either statistical or symbolic. And then you predict what is the bird type. Unfortunately, this method was very inspiring, but there's a poor trade-off between accuracy and explainability. They struggle to find the compromise. And so if you look at the concept bottleneck models here, the concept is very rich, but the accuracy is very poor. And if you see the scaling, how many concepts, how many properties, how many features you can add to the object, then very quickly you just get to a plateau here and you don't progress anymore. And more than that, if you want to say, okay, let's add capacity, I have my same concept here, but I'm going to allow some flexibility in the network. So these neurons are standard neurons without any knowledge in it. So I put my knowledge in the red ones, and the yellow ones here are the same as before. They can be trained statistically from the data. Thinking, okay, I'm going to open this flexibility I was mentioning before. If the concepts here are not covering all the data, by opening this, I hope that I'm grabbing the statistical from the data I get, and so I cover everything. So I get this flexibility that symbolic is usually missing. What happens? Everything goes to the statistical part. Nothing is going anymore through the knowledge. So here you have the concept bottleneck model, but here you have the hybrid, and you see that the concepts that are intervening is almost no intervention. Yes? Because statistics is better. That's what the deep network decades told us. But we still need to control them, to frame them. And we found a way to do something which, again, we are not solving the problem, but we are making a huge progress. What we have proposed here is that you have the same neural network that is giving you a latent code, a vector, that is now representing your pixels. And you're going to train here an embedding generator, so that you're going to represent your feature here, like long beak, by, again, neurons, but you learn them from the data. And then you have your layer where you store all the features that you have learned, and then you predict your bird type. We did something a bit more sophisticated than that. So you start from the latent code, and here you see that you have actually 2 branches for one concept, which is the concept is active or the concept is inactive. That means that if the bird has a long beak, it doesn't have a short beak. While if you leave statistics doing things, the gradient, the computation can spread information everywhere. So it's kind of fuzzy knowledge. If you do this a bit more strictly here, then you either allow the long beak or you disallow the long beak, discard the long beak. And so if you do this, you can get a probability of this picture to get a long beak. That gives you another advantage, is that this probability here is a way to make human intervene. The expert is going to be intervene. So if by training from the data, there is bias in the data, the expert wants to correct the probability because should not be a so high probability on long beak, then here you can control that probability, concept per concept. And so you can do this for all the concepts, and here you have control on all these concepts. And you get your, again, bottleneck layer where these concepts have been trained, learned, and controlled by the probability here. And so then you can predict. So what we get from that is that we were getting from neural where you have unsupervised embeddings. The embeddings are computed by statistics from the data. Symbolic is supervised scalars, is this or that. And with our neural symbolic approach, then we have a supervised embedding, but that can be controlled to be active or inactive in the field of what we get. Of course, if I present this work, it's because it works better. So remember, we had concept bottleneck here. Here we have the accuracy of the non-explainable models, and we are here. So that's pretty efficient. We get a scalability far better than any other method that was existing. And also, we can react, as I was explaining before. We can control here the concepts if the data are not good enough or biased a bit. We can control the concept here, intervene in the model, so that we get a lot better prediction from what we had before. So if you want to get more into this, that's the NeurIPS paper that was published last year on this, and there are some recent publications that are pushing this in different directions on graphs and on more explainability. Okay, one thing that I should stress here is that it's not perfect. Why we are not solving the game? We are not killing the game because we still define the concepts. So if you missed that, I don't know what, there's a blue dot here on the wing, you still don't capture it. So you go only through the knowledge that you have given beforehand. You learn it related to the data, but this is predefined. So we'll have the question on how to learn this concept from the data. But before that, I'm going to explain how we have been still working on this idea of concepts for another problem, which is how can we reduce the amount of data you need to train this deep networks model. Okay. And so the idea is back to this idea of concept. This is a dog, and not only it's a dog also because it has 2 ears, a nose, and a muzzle. And so how could I use that knowledge that these data have been annotated? I have a database of objects, and I have the dog, but I have also the ears, the nose, and the muzzle. And so we have been thinking of using this idea of concept in what is called the active learning paradigm in machine learning, which is, that's my boss at ANR, at the National Research Agency, and she's like, okay, sorry. Okay. Obviously, I have some work to do when I'll be back at the hotel. So active learning is, I want to select how many data I need to build my training set, not using a huge training data set that is requiring to hire some slaves, interns, sorry, we call them interns, to annotate data, you know. And so instead of hiring interns to annotate data, what we want here is to benefit from the knowledge that we could have to use as few data that we can to train the model. And of course, the idea is how can I select which data should be used to train my model? So that's the idea of active learning. I have few training data. I'm building a model which is not very good. I have a huge pool of unlabeled data, and what I want is to select which data I should annotate here so that I'm increasing my training set and then improving iteratively. And it works. I mean, active learning has been searched for decades, in particular using supervector machines. What we are going to see is that we achieved similar performance, at least similar performance to other standard active learning strategies. The capability of discovering unseen data distribution. We have been able to apply this to both regression problem, object detection problem, and of course classification. And it classifies better respecting the given knowledge. I will explain this. And of course, the computational time is far lower. So first, a little bit of state of the art. Most of the active learning strategies that are existing around are based on statistics, on distribution. And so you're going to look for uncertainty samples. If your model is uncertain on a sample, probably that's a very good sample to give to an expert that is going to annotate the data. And when the data are annotated, then you give them back to the model and it's going to improve. You have plenty of ways to measure uncertainty, margin, entropy, etc. The margin is in particular very standard with supervector machines. You have also the opposite, so that's the proposition from Yoshua Bengio and his colleagues, that is, instead of looking for the most uncertain one, let's start with the most certain one. So you start by the mode of the distribution, start by the most central points. Then, of course, these distribution models are a bit biased by the metric that you use. And so there have been some diversity strategies that says, okay, if you pick some samples here, at the next iteration, go to pick them somewhere else. Otherwise, you just dig here at the same place, and you don't cover the distribution. So you see that most of all these approaches are based on distribution. Of course, to match with non-symbolic AIs, we have been getting back to a bit of logic, particular first-order logic. And what is first-order logic is that you get the predicate A and the predicate B, and then you get the predicate C. So this rule is valid everywhere. And it relates atoms, the A, B, and C, to the same domain. You can apply this to different domains. For example, the number of mosquitoes can be related to the dengue infection. And so many mosquitoes are related to high dengue infection. You can also use this first-order logic with functions and properties and predicates, sorry. So here the function is the mother. Over again. Okay. Better? Yeah, okay. And so you have the predicate that says I can relate the class albatross to a larger class like albatross, if albatross then bird. One way to transform this logic representation that more or less everyone can understand to numerical formulation so that I can use them in a statistical model, you can go through T-norms. And there are plenty of, not plenty, you have several ways of using T-norms to transform these logic operators into computation. And we ourselves have been using the product T-norm. So let's take a very standard example, the XOR. So here I can replace this XOR operation. There will be some illustration in few slides, so it will be easier. I can relate this to, with the T-norm, product T-norm, I can represent this with that equation. And so using this, I can then define the predicate using the sigmoid. And so I can relate a statistical calculation with neural networks with this logic rule that I have here. And if I want to parameterize this formulation here, for example, if I'm having a logic rule that says a person get access to insurance or not, and that the age of this person is involved in getting access to the insurance, then this age can be modulated, can be changed, parameterized by the age that you have here in the signal. So the idea is that we are going to look for samples in our training set that are not respecting the rules that I've been taking from my knowledge. So a dog, if I get ear, nose, and muzzle, I should get a dog. So if I have an image with ear, nose, muzzle, but not dog, that's probably an interesting model, an interesting sample to annotate and say, okay, that's a dog, and retrain my model with this, because that sample is not respecting the knowledge I have on dogs. And so that's what we proposed. We have been proposing to select the samples that are respecting the least the rules from my knowledge. The more violation rules I get, the more the sample is interesting for. And so here we are back to the XOR problem. Here what we see is that this first corner here is black. This second corner is black, so let's say 0. And the bottom left and the top right are 1. And I want my model to discover this by sampling the space. By using these equations here, that the logic rules that I transform into equations, I can train my neural network to find the best samples to decide, okay, I understand that now these two squares are 0 and these two squares are 1. And you can see that I don't need to get a lot of samples because quickly these rules are saying to take the samples which are on the boundaries here. Okay, just to be clear, there is no magic here. It's obvious. I know from the beginning that by the equations, here it's 0, here it's 0, here it's 1, and here it's 1. What we show with this example is that if you have a perfect knowledge, absolute, you cover the world, then our model is finding very quickly the right samples to give to training the network and predict perfectly everything. But here we have the perfect knowledge. We know the equations perfectly. Of course, if you go to a real-world problem, it's not that easy. Here you, on the CUP dataset, which is a dataset of plenty of animals, here you have the different rules, the different logic rules that you get, but maybe some rules are missing. So it might be an incomplete knowledge. So it will not be as powerful as we've seen before. And on the regression task, here what I want is to predict insurance charge. And so again, here I'm using some rules that are coming from, for example, companies. And I can transform these rules into mathematical computation and so train a network with this. So here you see the age that I was mentioning before can appear here. We have been also using this for object detection, as we have seen with the dog, the ears, the nose, and muzzle. And so we transform all the rules that are defining what is a dog, what is a person, what is a bird, into a mathematical equation, and we train our model with this. So what we see is that here you have plenty of contenders, the standard statistical models, and we are at least as good, most of the time better. We can see that we converge far faster than them, of course, on XOR because we have the perfect knowledge. And on problems, the standard IRIS dataset, animals, and CUP 200, when the knowledge is not perfect, still we are competing, and we at the end, we get better the more knowledge we give. Here you can see the behavior of all the contenders techniques that I've mentioned before based on statistics. Some of them are even missing. There is this point should be 0 from the XOR equations, because it has to explore this statistically to be able to retrieve this classification. So, of course, the more knowledge we get, the better it is. We have given knowledge little by little. So expanding knowledge, so if you work with a biologist, with a museum curator, the more the person gives you knowledge, the better is getting the model. If we don't have knowledge, we don't have experts, still there are some techniques, some on-the-shelf explainable AI techniques that allow us to extract the knowledge from the data, depending on which problem, of course, not always. But then you see that the score, if we give this knowledge extracted from the data, the model is working perfectly. And what we can show is that if we use our technique on the increasing the training set with the active learning strategy, that we are building the training set iteratively, and we compare how on the test data, the knowledge that was known before at first is respected or is still valid. You see that with the statistical approaches, distributional approaches, then the more you train, the farther you go from the knowledge coming from the expert. Of course, ours is staying aligned with the knowledge. That's questioning these kind of approaches, because then you explore the space in ways, in areas that experts would never have proposed this. So to summarize this second work that we have been doing, we have incorporating symbolic knowledge in selecting samples for deep networks techniques. It provides better classifier which respect the knowledge, as I was showing in the very previous slide. It can be applied to any scenario and any kind of data as soon as you get knowledge. And it's, of course, not computationally demanding. Some still open question we are working on currently. Something that we are going to hopefully publish very soon, that this model can be debiasing. If you use a deep network to classify images on the celeb A datasets, so that's faces of celebrities, these data have been annotated by humans, and the classification, the annotation are questionable, but still are related to plenty of questions, plenty of features. And so the result that is coming from the literature is that if you look for attractive women, which is again questionable by itself, you get pale skin, not chubby, no glasses. That's what the network has trained from the statistical data. And that when you look at what has been trained is these kind of features. With our technique, we could say, unlearn that attractive is pale skin. You say, this is violating my knowledge. Pale skin has nothing to see with attractive. And so you can retrain the sample with the right sample so that the model is debiasing from the knowledge that you get. And that's what we are working on, and it's currently working. You can use this in active learning, in an online learning process. I'm going to skip this. And of course, again, we have an issue here. We have said that the dog has ears, nose, muzzle. But maybe we should say mustache or something else. So we are exactly as in the first work. It's really related to the concept that you have defined. So if you miss something, it's not in your scope. And so that's why, yes, if you want to go further, there is an extensive formulation in ICLR submission. The reviews were very rich and very interesting. 1 minute will be fine. But don't look at the area chart that discarded our work. The other were giving us very interesting feedback and grades, but still not going through. So hopefully it will be officially on ECML 2023. But still, I recommend the reviews, which are very interesting to see the work. And so, of course, we are currently working on this cave 8 of this work, which is, can we learn the concept from the statistics directly? Can we not relate on the knowledge that is given by an expert? Can we extract something from the data directly? And so there are several works that have been proposing, mainly for visualizing and understanding how the networks are working. So you have the concept relevance propagation, you have the network dissection, and that's exactly what we are exploring, but for a different purpose. We are exploring how this work that we're focusing on explaining why the network is predicting there is a dog in this image. But the way that we're building this explanation is actually very interesting to say, in that part of the network, I discover the nose, the snoot. In that other part of the network, I'm discovering the eye of the dog and the furs, etc., etc. So reusing these techniques that were made for explainability, we can reuse them to define the concept from the data and then feed our model that we have seen before. And so that's hopefully a virtuous circle that is going to work together. And I finished. So if you have questions, I'm just pointing here some action in France that I'm supporting a lot. So since last September, I'm publishing one of their posters after every of my class, each of my class, and so in talks also, because important actions. Thank you. Here? Yes. Yes. It's yes. Again, that's yes. That's yeah. Very good question. That's actually related to this question of knowledge. That is how much the model is exploiting of the concept that we have in the knowledge base. So here, the more you go on the right, the more concepts are exploited by the knowledge, by the model from the knowledge to build the decision. So here you use not all because some rules are redundant or some other are more generic, more general. So you may not use 100% of the knowledge. You're very efficient in using the knowledge, but not that efficient. Here you statistically that's whatever ResNet or whatever you want, but there is no concept. They are still, if you relate this to the concept from the knowledge base, you can still find the network is, as I'm showing at the end, capturing something related to the nose, maybe the first, but poorly compared to all the concepts that you could use. Mm-hmm. Yeah. Yes, but not by us. This Cube 200, the animals dataset I'm mentioning also, they are coming with rules. I mean, that's made by the colleagues from Neurosymbolic. They have built the knowledge base that you can use. They may not be actually absolute. There may be some rules that are not in the... No, they are given. Yeah. Actually, yes, actually these rules are pieces of your knowledge graph. And it's the way we write here, we expose them here, it's because if you want to relate them to some predicate, to some operators, then you need to get something simple. The hierarchy in these operators is not that easy to formulate, so you flatten your graph, your Yes, yes. Yes. I mean, whole knowledge, again, that's where the symbolic has been facing difficulties compared to statistics, that this wall is never absolute. So, but yes, you can use the wall knowledge, yeah. That's. Thanks to the work from the colleagues from knowledge representation, it's not, we use their tools to extract all these rules that we have seen before. All these can be extracted from. So it's kind of for free. If it's more in terms of computation compared, we are a lot cheaper. I didn't put the slide, but it's in the paper. We are very, very cheaper. But I don't count the building the knowledge. And it's once. It's offline and once. But if you have the knowledge, that's, of course, I mean, crazily more efficient. In our work, you can because in the first yes, in this model here, you can work on at the level of concept. That was the point of this. For example, you could. Yes. still here I am in a model where the concepts are predefined. I'm not extracting them from the data. So if there is something missing in my knowledge base, I don't have it. Another way to interact with the model is what I was explaining here, is with this active learning approach. And that's what we are working on in the debiasing approach. That is the debiasing method. That is, if my model has been biased, can I refill it with new samples which are correcting the rule that was I didn't want it to. Exactly. And something which is for me very important is that this is not for AI experts. Here, a biologist can say, okay, this rule is not valid. Doesn't have to know whatever on your network or exactly. Domain experts can interact with all this. Yes, which is one of the goals also, because I've been working with domain experts for decades in projects, and the interface is very costly to understand what they have in their brain, and for them to understand what you can do or not. And with these kind of techniques, they interact directly with the model. Thank you very much.
So, thank you for having me. It's always a pleasure to be at the Institute of Mathematics here. So, just 2 words about the institutional affiliation. So I'm a professor at the Institute for Theoretical Physics at the São Paulo State University here in the city of São Paulo. And that is the complex system group applied to biology in general. And I'm also a member, actually a founding member of this COVID-19 observatory, which is a group of researchers, which is not an institution. It's a group of researchers that has been very, very instrumental during COVID in many aspects, but modeling and data analytics, and also science communication. So I will talk about some aspects of COVID-19 modeling, and also not statistical modeling and mathematical modeling with data from Brazil. And I will obviously talk about the experience to do this in the context of this observatory. The first thing is that's the epidemic curve for the number of new cases per week in the state of São Paulo. Okay? So first thing I want to notice is if you open any book on modeling epidemics, you'll never see anything like that. Okay? So it is this represents that the system that we are interested in is actually much more complex, has many more factors than what we usually think to be the models in epidemiology. Okay? It has factors involving behavioral factors from the society, and then also factors which are usually not taken into account, which are evolutionary aspects of the virus in this case. So just pay attention. So there's some points in blue and some in red. Okay, and at the end I will explain at the middle of why there are some in red. And here you cannot read because it's not the definition is not good. This is reported with respect to the date of first onset of symptoms. Okay, and this is also something I keep in mind. I will explain why this is done in this way and why it's important to do it in this way. So, just some comments, general comments before I go into our work, actually. So, modeling COVID-19 and at the very beginning was very different from what we have done until in 22 and 23. So first, we had compartment models, agent-based models, stochastic models. We still have this kind of thing. And the first thing people calculated is this R0. And R0 is the number of secondary cases created by an initial case in the case of the beginning of the 0 is for time 0. Okay? So lots of calculations of this has been done. R0 is kind of 2.5. And this connects to a total epidemic size if you use compartmental models. And this would give you a total epidemic size, the number of people that had the disease, right? And at the end of the epidemic. Well, the epidemic didn't end, actually. But, you know, the usual epidemic models, this would be an SIR modified model, which would give you, at a certain point at the end, I would say how many people would be affected. And this, with 2.5, that would be, I think, like 80-something% of the population. So that's what we knew and what was discussed in 2020. And people tried to do non-pharmaceutical intervention scenarios, which is very difficult to model, actually, because it's a problem of behavioral. It's not just that there's a law saying you cannot go out. And there's compliance with the law, which is still more difficult to. Obviously, we had no knowledge of vaccine efficiency, behavioral effects. nobody expected until October 2020 or November 2020 that the immunity was waning and decreasing in very quickly, actually. And what we see is that the immunity is decreasing because of variants. Okay? But this was not the case in 2020. Nobody took very seriously that immunity was decreasing. And then there was this famous prediction from Imperial College, from a group of neuroscientists, that if no action is taken to mitigate the number of infections, the UK would have 5,000 deaths and the US 2 million. Then you say, well, here comes a first comment that this is obviously taking a model which does not have a behavioral compartment or aspect, in the sense that there is no such thing that if you have an epidemic that kills people, that there is no such thing as no action. There's always action. Even if the government does not take action, people will take action. Okay? So this is obviously a point that was not taken into account by this group. And then there's a communication problem. But this has been said, okay, they are just making terror about us. It's not terror, actually. It's not so bad. I mean, there's a million. It's order of magnitude correct for US. So after all this time, after 3 years, now we have vaccines and we know the efficiency, and we can put them into the models. It's nice. We know waning immunity is a reality and can also be put into models and can help to explain long-term trends. We also know that long-term forecasts have very limited applicability. That turned out very clearly, okay? Because the evolutionary aspects of virus and so on. And there's a real need that people I think now understand clearly to quantify uncertainty, okay? Because you should always give an interval of credibility interval or something like that, and this should be communicated when you communicate to society. And this is difficult to communicate, but that's essential. And so also science communication emerged an important issue in the epidemic. So, okay. So just as one crash course in 30 seconds, epidemic models, usually the most usual ones, just divide the population in classes: susceptible, infectious, recovered, and then there are the usual SIR models, which give the rate of change of susceptibles, infected, and removed, like this. And then there are generalizations with many, many compartments, okay? And for any realistic model, you also have to take into account age structure. So these are divided in ages also. So there's much more complicated models than this. And one thing that I would like to mention is that we cannot measure S. We cannot measure the number of people that are infected at this point. We cannot measure the number of recovery. None of this is measurable directly from epidemiological data. Epidemiological data are usually the number of new cases per day, which is not written here. Okay? But I mean, can be derived. But anyhow. Okay? So such simple models obviously are not realistic, but they help to define the concept like R0 connected to the model, and which generates, which can be generalized to complex models. And there's a relation between R0 and the final size of the epidemic. There's a classic figure and textbook figure. When R0 is 1, obviously there's close to 0, it increases very, okay? So during the epidemic, there has been a lot of confusion between final size of the epidemic and the herd immunity threshold. Herd immunity threshold, like with R0, equal to 2.5 is 60% but the epidemic overshoots this and goes to 80-something. So these are nice models to explain to people, but these are not the models that are used actually in real-world applications in the case of COVID and then also in other cases. Okay? The point about COVID is we are modeling an ongoing epidemic, which poses some very particular problems, and I will talk about this in a minute. So I will focus on two examples and that have been developed by the group of the observatory. One is the way to calculate RT. RT is the number of secondary cases which one primary cases generates at time t. Time 0 is the beginning, and time t is a certain time where you have already some people that are removed, have been recovered. Okay? So, and the second thing is a work about the gamma variant of SARS-CoV-2, which was very, very important in the city of Manaus and also in all Brazil. And I will show you how to use a model, not to make a prediction, but to estimate parameters of the epidemic. So the first thing is you don't need a model of a compartmental model to calculate RT. A lot of people use models to calculate RT, but state of art is actually much simpler. There is a relation between RT and I. I is here's the number of new cases per day. It's the incidence. It's not the I of SIR. I have used that model later. So, and the R at time t, and you have to know the incidence, which is closer to what actually can be measured in the epidemiological data, the number of new cases per day. So, I mean, you went up even on the newspaper, so many cases today we have. Okay? But you also need something here, which is the distribution of generation or serial times, which is what? Generation time is, I say I got infected now. And I, in fact, will infect somebody, okay, after some time. Okay? So this is the generation time. And this depends from case to case, so you have a distribution instead of one particular time. Okay? But this is a very difficult thing to know because you don't know when you get infected. People don't know this. So you use a proxy. And the proxy is the zero time. Zero time is I got infected, but then I get my onset of symptoms now. And then you look when the onset of symptoms of the people that I will infect will happen. So the difference between these times of onset of symptoms instead of contamination and non-contamination so the onset of symptoms is this distribution. And what people use, this is more or less, I mean, the same worldwide. Okay, that can be, because it's also difficult to measure this. Okay, because this has been measured mainly at the beginning in China, because they had very strong restrictions, and people could more or less calculate this. And the incidence, well, that's what usual epidemic models give you. So this is, okay, this is the way that you can calculate this, but then let's look at the data. Okay. It's nice, I know the incidence. Okay. It's not like that. And this is very dependent on the surveillance system for the country or the state or whatever, for the region you are analyzing. So the first thing you don't really know is, so in Brazil, best data that you have that you can trust to a certain level is the number of severe cases, which are the people that got hospitalized due to COVID. And the number of people that went to health services and get COVID diagnostic, but didn't go to a hospital is a data that's lacking, actually. So what people do is, what we have is the number of severe cases, okay? Then we can use the time series of hospitalization as a proxy for the number of cases, right? There's a hypothesis that the relation between number of cases and number of hospitalization is more or less constant, which can be always discussed. But then there's a problem. So every case has to be assigned to a certain time. So I have a case here. What is the time I should assign to this in order to make a plot? Okay? So there are two possibilities usually. Now, one possibility, which is the data that you saw by the government and so on, that's the dates it's notified. There's a notification day when somebody typed in the system that there was a case. But this is not a good time to use, because this is an administrative thing. And there's a long delay between the case, being a person going to the hospital, and actually appearing on any table. So, and this time mixed the epidemiological dynamics with the administrative balances. Right? So what you should do is the date of first symptoms. That's why I called your attention at the very beginning. Okay? Date of first symptom, which is something which is reported on the databases. Okay? But then you have a problem. Okay, so the date of onset of symptoms. But then you have a problem which is the following. If I want to know the people that today or yesterday had the first symptoms, but if notification takes 2 weeks to appear in the database, I have no idea what's happening now, or yesterday or the last days. And this is an ongoing epidemic and you want to make surveillance with it. So you have a problem here. So what you have to do is, using the statistics that you have about the delay and first symptoms, is from the first data from last days to do it's kind of statistical analysis to estimate the number of new cases today. So you calculate this. So that's called nowcasting. Nowcasting comes from a play with words like forecasting, but it's not for. It's just to know the cases now because they have not been reported. Okay? So here's an example. But for instance, if you take a typical curve here and of cases, this is from Belo Horizonte, and you get always something going down here. Okay? Because it had not been reported cases. So when you do this nowcasting, which we developed together with people from Rio, and then you get here a prediction of the number of cases. That's the average, and this is a credibility interval of 95%. So that was the first product of the observatory, was to give the nowcast. And then you use, for instance, that's the example from the beginning. This is the nowcasted part. So this has been estimated here. It is not the data that has been reported there. It's still waiting for the report. And this is the consolidated. So with the nowcasting, now you can go for your formula for RT, and then you can put this and calculate RT, and then using the nowcasted data and the way to calculate RT that I explained just a minute ago, then you have this kind of thing to calculate RT. Okay? So we decided that in 2020, actually, we didn't want to publish paper at that time. We made a page which had been very popular, and where you can have for all all states of Brazil, some of the cities, and this kind of calculation of the estimated number of cases and the RT with this method. Okay? So just to finish the discussion about RT has been a lot of people discussing this, okay? But you have to pay attention that the knowledge of RT and R0 is at the initial phase of the epidemic, which allows you to estimate the final size or herd immunity and so on. It's something that is valuable information, but when you have low number of cases, RT is not so interesting anymore, because any small outbreak, which does not necessarily represent a huge development, will give you a RT bigger than 1, and then it's not anymore a good policy instrument. It's still a characterization of the epidemic situation, but as a policy instrument, it's not so good. You have to do policy, take into account RT, but also other indicators. Otherwise, if you go, there are people trying to do RT and automatically setting restrictions and so on, and this is not okay, mainly for smaller cities, where you have a lot of stochastic dynamics going on, which is finally gives you an RT with a credibility interval of a size that makes it impossible to use. Oops. Okay. So my second example is the use of models to estimate the parameters connected to the gamma variant. So this is the epidemic curve for Manaus. They had a very big epidemic at the beginning. People thought they should be at herd immunity. And then you have super high thing going on. Okay? So what we did is, okay. So we have the data, which is the incidence of COVID of severe case with now casting at the time. Okay? And we also use the proportion of case due to gamma variant, which people were doing, people from another group. We have contact with the group of Esther Sabino, and they were doing analysis about the proportion of cases which were due to gamma variant. And our objectives were to calculate the relative transmissibility of the gamma variant with respect to the wild type. Okay, so people said the gamma variant is much more transmissible. But we also included the possibility of the gamma variant, the person that had the wild type, not being immune to a certain extent to the gamma variant. So we also want to estimate the proportion of reinfections. Okay? And what we use is a compartmental model, which is more or less simple. So you have a compartmental model for the wild type. You have exposed, hospitalized, asymptomatic, infectious, but not hospitalized, a number of sudden deaths. Then you kept it recovered. You have the same thing for the gamma variant here, but there's a connection here. The force of reinfection. You can leave R1 and go and to be infected by the gamma variant. Okay? So all of this is divided in 3 age classes, which is what we call a not so complex model, because we have kind of young, adults, and elderly. We could have 20 classes, but this would pose a problem with parameter estimation. So we write down the equations for this model, and we will fit the model to the epidemic curve. Okay? And this fitting will give you some parameters. And one parameter will be the relative transmissibility and also the force of reinfection. So this is the data about the percentage of gamma variant with respect to the total number of cases. This is our fit, actually, from the model to the cases. And so going to the results. Oh, yes. We found that the relative transmission rate of the new variant was kind of estimated between 2.45, more or less 2.6 times more infectious. But this could only be, let's say, true if you have enough people to be infected in order to explain this. And so do you have reinfections? And if you go before, I mean, the force of reinfection then will allow you to calculate the percentage of reinfection. I will show you. But there also something which is a free parameter is the prevalence of the previous infection at the start of the gamma epidemic. And this gave us 78%, which is very interesting because previously, some months before, there have been a group from USP and from Imperial College, which works with blood banks in Manaus, and they estimate parameters from that, and they found 76% of prevalence at a certain point, and this had been enormous politically used because people say 76% means there can be no new epidemic. Then obviously you have a variant. But so we actually confirm in the sense that the model, the best fitting of the model is giving something which is in line with what this group found before. And so the results about, okay, that's what I just explained. And the fitted model attributed 28% of Manaus cases in the period which starts at the beginning of November 2020 until end of January 21, at 28% of the cases. Okay? So, which shows you the importance of reinfection. At that time, this was not so clear for people that reinfection was important. It obviously only became important because of the variants. Okay, so people suspected this, and now it's clear for everybody. Okay? At that time, it wasn't. Okay, we published this some journal, and this is also in line with the blood donors bank, which had been estimated later, which gives you something on this range here, which agrees with what we have here. Okay? So this is an example of how you use a model, not to make predictions or to try to predict long-term trends and so on, but it is a model that tries to explain why you could have and what are the parameters connected to a new variant and why you could have this kind of explosion of cases in this. So, okay, so these are my two examples. Our group did a lot of other things, like lots of vaccination problem, best interval between doses, problem of vaccine delivery, vaccine strategies in the context of gamma, child vaccinations and the importance of child vaccinations, and also more theoretical work, which is how to include percolation across households in an epidemic, because you have when you have non-pharmaceutical interventions, that people don't go so much outside, but they stay. But you could have threshold for percolation between households. Okay, so we have also a model for this, and we have a proposal how to use this in a compartmental model, not a statistical, which is a more theoretical journal. And this one I might want to make a small comment. This is is a Bayesian analysis of estimating the impact of the implementation and timing of the vaccination program in Brazil. And so we use the fact that from the beginning of the program until more or less July or August, only people over 60 were vaccinated. So the impact, and then you could see, and the number of cases, people that are in this over 60, to the rest of the cases before the vaccination was more or less constant. So you use the fact that the other has not been vaccinated to calculate how many people would be infected if there were no vaccination. Okay? And then you look for the difference. This gives you an estimate that this quantity, 165,000 individuals of age above 60, were not hospitalized in the first 7 months of the vaccination program, which is the time when they started to go to younger class age. And an additional number of 104,000 could be hospitalization could be averted if vaccination started earlier, because now we can only translate from a certain, you can simulate if I started earlier to vaccinate. People know it. We had a problem with the start of vaccination in Brazil. If you have vaccinated earlier, you could have avoided more hospitalization, and then you can also calculate how many lives were saved. So it's 58,000 lives could have been saved by vaccination, and we could have avoided 47,000 deaths if we started to do the vaccination, say, in January or whatever, okay? Which actually only started seriously much later. So this is also an application, not from compartmental models, but also, I think, a very important aspect which had impact on policy decisions. And then, well, there's also school modeling, reopening of schools, and a paper, an opinion paper about the need of genomic surveillance in Brazil, which was also an issue that was very much debated. So before I finish, let me just make two other comments, which are not on the slides, on two things I think should be taken seriously and should be debated better, at least in the Brazilian context, but I think that more or less everywhere. So one is about multi or interdisciplinary research. And we could only do this, and this was a very exceptional situation, because our team is multi-disciplinary. So we the people of modeling, we didn't know how even to read the databases, which are important. But people from public health knew this, and they knew the problem of now testing and so on. So we didn't join at this. We could do the analytics and the models, but they were very important in order to show us what is epidemiological important and which can have any impact on policy decisions, or at least at public opinion. Okay? So I think this is very important, and I think in the particular case of Brazil, there's not a real venue, a place of real interaction that could for these people. Okay? So people are in the mathematics departments, I'm in the physics, the people are in epidemiology, and they do their jobs, and there's no permanent place to have these discussions. And I think there's important that, and this has also other implications, I can discuss later, but it would be important to have some institutional background, not new institute, but something, a center where you have a more regular and long-term interaction between these different communities. The second comment is what we at the observative we are requested all the time by media, by TVs, by journalists, and so on. And it is important that the scientists, which are involved in such kind of things that are of great interest for the population, get a better training to manage communication. And obviously also we would expect that the journalists get also better training to know what science is important. And one very difficult aspect of communications was that journalists didn't know who to believe. There are scientists that with best good faith calculated some of these parameters completely wrong. And they were from USP, were from UNESP, and so on. And then they had the same affiliations, and they said that they are as good as us. That's a problem. That's also would be important to have an institution, an institutional voice. Like, for instance, I remember very well, followed the news from Germany, the Robert Koch Institute, and the German government could not just dismiss Robert Koch Institute. They are important. I think probably in France also, if the Institut Pasteur say something, people have to take it into account. Okay, and so we are lacking this here in Brazil. Okay, so I have 5 minutes for questions. Thank you very much. Okay. So now, sometimes now it's just if you have an increase of number of cases, usually you can fit an exponential, and maybe just the growth parameter of the exponential gives you already something. But actually, so this would be an indicator of how fast we are going, and the problem is we don't really know the number of susceptibles, okay? which makes it kind of impossible to know what would be the size of the problem. Okay? You have this kind of waves. Now Omicron something else, and you have the wave. But can you predict the size of this? And I don't think we have the numbers. You would have to need genomic data in real time, which is yeah. You go to it? Yeah. I totally agree, because first there is this real problem that I don't have this problem. I'm an old man and I'm already full professor and so on. Nobody can do anything. But for young people, it's different. And then, because I'm Institute of Theoretical Physics. Once, many years ago, I was theoretical physicist, and I stayed in an institute, but I have a group that does modeling. And for instance, all my students have to be physicists, because if they wanted to have a master's or PhD, they will have to go for quantum mechanics and so on. So many of them were actually pretty okay. I mean, I had a lot of students during this time and so on at work, and they found something. Master students usually went abroad, where you have, overall in US and UK, you have more possibilities of this kind of interdisciplinarity environment. For instance, in Oxford, I have a collaborator, which is a mathematician, which is at the medicine school. But here in Brazil, it's also for the students, it's a problem sometimes. Because if for instance, we had a very, very important group of, at the Faculty of Medicine, doing modeling, but they had always a problem with having students, because the student would get a degree in pathology. Then what you person said, no, but I'm a mathematician. How will I then get identified as a modeler, but I get a thing and something strange for me. So that's true. Yeah, well, thank you.
So as I said, the talk of today will be about the MIMOVE team, middleware on the MOVE team at Inria in Paris. And the title of the presentation is a middleware-based approach for enabling interoperable IoT environments. So here is a brief outline of the presentation of the day. So first I will start with a short presentation of the MIMOVE team. Then I will spend some words on what is a smart city, IoT, and cloud computing. Then afterwards, I will talk about the interoperability issue in IoT, then our solution for deal with this issue, which is called Data Exchange Data Synthesizer, XMS for short. I will have also a talk about an integration we have between OpenStack, one of the known cloud platforms, and XMS. And finally, I will give a hint about the research direction. So for short, I am Zakaria Ben Omar. I hold a PhD degree from the University of Messina. I am a research fellow at Inria Paris within the MIMOVE team. Before, I was a former member of the MDS Lab, Mobile and Distributed Lab in Italy. I am also a member of the OpenStack-based Iotronic Working Group, a project that's working on IoT and OpenStack. And also, I am a member of the Italian National Inter-University Consortium for Informatics. And specifically, I am on the group working on smart cities, and I had the opportunity to work on several test beds in Italy about smart city. So for MIMOVE, we work on R&D related R&D topics related to emergent distributed systems. One of those projects is called XMS, and we work mainly on IoT, cloud and edge computing, crowd sensing for smart cities, and also on data stream processing. We have been involved on different EU projects, such as the 2020 Core Evolution, FP7 Connect, and also we are now involved on EU and national projects, such as the Horizon Europe CEDIMARC, and also the project where we are on which we are working now, which is called Smart City Cloud Platform for Smart Cities, CP4SC, led by Atos, and it has also Ericsson as an industrial partner. So here, talking about the smart city, I will here have some words about what is a smart city. So smart city can be defined as a set of policies and strategies that use ICT technologies to provide added value services. Of course, it drives efficiency for cities and public administrations. It creates an efficient and competitive environment for businesses and companies, and also it improves the quality of life of citizens. So from here, we can take the three stakeholders of the smart city. We have public administrations that are interested in traffic control, air quality monitoring, trash management, autonomous security systems. Then we have companies that see the smart city as a fertile landscape where they can drive innovation. They provide new services, of course, to get more gains, and also they are interested in money saving because we can talk about optimization for transportations and logistics. Then we have the citizens. They are more interested in parking solutions, real-time traffic jam, predicted traffic timing, and also we have the connected houses and offices. So to build up an IoT management system, we can pass basically by three phases. The first one is the monitoring, where we use a set of IoT devices devices in general to sense, observe our environment and phenomenon that we have. And of course, these devices, they should communicate and connect among each other and with other systems to transfer the data. Then we have the second phase, which is the modeling phase, where we have to get the data, analyze this data, and also optimize it to get the value from this data in order to present it or make it or expose it for the users, or even act in a city scale. So for this talk, I will basically focus on the monitoring phase where we use IoT devices. So here in general, we have a set of categories of IoT devices. We can mention the microcontroller boards or single board computers, which are very widespread nowadays. We can use them, of course, with a set of sensors and actuators. And they present or they provide a wide range of connectivity options. We have 3, 4G, LoRa, and so on. Then in a more general sense, we have the smart objects, because here we are talking about the consumer appliances like the smart home kind of technologies. And also in this case, we have a wide range of connectivity. Then in a general sense, we have also the smart homes are very well known, and we use them with a set of course, a set of sensors on board. So the question is how we can deal or how we can manage the data that we can get from those IoT devices, how we should interact, how we should manage the heterogeneity of these IoT devices, their protocols, and so on. And to manage the data, of course, we can think about the cloud, because the cloud provides theoretically unlimited amount of resources. So we just need to send the data to the cloud and do some analysis here and build our applications. So in general here, I'm talking about what I call here the vertical approach. It's one of the approaches that we can use in IoT, where we have the applications that can interact with the IoT devices through some dedicated or some protocols using some SDK like the ones provided by Google, Amazon, and company. Then we use in general either open source or proprietary protocols like MQTT, AMQP, and so on. And also we can, or nowadays we use what we call agent for computing to have processing nearby the IoT devices. The issue that we have here in this vertical approach is the vendor lock-in. Because if I buy a device from Amazon, of course, I cannot use this device to develop an application using the platform of GCP, of Google Cloud Platform, of course. So once I buy a device, I am locked in, so I cannot use another provider. Of course, in the smart city, we have plenty of devices, because we are talking about devices that are constrained, so we have to use protocols that are suitable for this kind of devices. We have a set of protocols like DPWS, CoAP, MQTT, HTTP, WebSocket, and so on. We have different communication styles. We have the client server, publish, subscribe, streaming, and so on. And also these protocols, they are reliable or unreliable, because we have the quality of service to manage. Then we have the mobile connectivity, of course. So to deal with this problem, of this interoperability problem, I will focus on a simple, let's say, example here of a transport information system, which is a system that uses a set of devices to collect data and inform the users or citizens within a city. We have here in the middle the team system, and we have a set of IoT devices, also some services like here the traffic estimation service. So each of these let's say devices and systems, they use different protocols, MQTT, semi-space, HTTP, WebSocket, and other protocols, of course. So in this case, the team system has to manage the heterogeneity of the environment, of course, and also the dynamicity, because we can have more devices that can be part of our system, and also some others, they can just go off. So this team system basically should manage this kind of mesh topology. It's not always mesh, but it depends on the number of devices and protocols that we have. So I'm calling it here kind of mesh topology. And here we have to develop a set of adapters, for instance, to make this traffic estimation communicate with all of these devices and services we should develop some connectors. So here, for instance, we have to develop, in this scenario, 21 adapters. 21 is too much, and it's an error-prone process, of course. This problem, it's a very well-known one, because in telecommunication, some decades ago, we had the same issue, and it was solved using switching platforms to reduce the number of communication channels. Also, we have the same issue in the software engineering field, where we have several applications that should communicate among each other, and we use the Enterprise Service Bus, ESB. So the ESB, in simple terms, it's a mediation layer that we put in the middle, uses a common protocol. So each service here will be translated. Each protocol will be translated to a common one, and we just communicate using this common communication channel. So for the team system, we imagine that we should have something similar. We use here a common protocol, and then we reduce the number of adapters to develop. So this is the situation we could have, is having a common protocol, and then I will reduce the number of adapters to develop from 21 to 7 in this case. And our idea is to go beyond this goal, and instead of developing the 7 adapters, I will make the application developer, or I will just, as an application developer, I will use the middleware that I will present, and I will not be even not interested, but I will not even develop these 7 adapters. So I will just rely on the system that I will present to do the adaptation. So we talk about an automated synthesis of mediators or adapters in this case, and it is called DXMS, Data Exchange Mediator Synthesizer. So here it's the general idea we have. So we have any protocol, a protocol X, that should communicate with another device or system that use protocol Y, and we should enable heterogeneous interactions in the mobile IoT. We use automated synthesis for interoperability artifacts, which is DXMS. And also we are interested in the quality of service, because we have to put the mediators, and we have to be sure that the quality of service is respected, of course. I will not talk about the quality of service because it's another topic, but I will focus on the synthesis of interoperability artifacts. So to start, when we started a couple of years ago, we had analyzed the communication styles we have in general in IoT. We could have the client server, very well known. We have one-way and two-way sync or async communication. Then we have also the publish subscribe. We have the data stream, and also we have the tuple space, also a protocol that is used in the system. So by analyzing those communication styles we have, here I'm representing the APIs or the primitives, what I have to give as a parameter to do to develop my app. So this is the APIs and primitives just for one way. Here I'm representing just the one-way communication, but we did that for all what we saw already, two-way, sync, async, and so on. So by analyzing those primitives, we abstracted them just using our, let's say, our abstracted primitives, post and get. So I can then represent any of those APIs just using our post and get primitives. So we just abstracted any interaction style using our post and get primitives. Then we are able to abstract the one-way, two-way async, two-way sync, and two-way stream using the post and get primitives. And thus we have abstracted any communication style like client server, publish subscribe, and so on. Then we are done with the part of the abstraction of the primitives. And now I will present a way to describe the things, because I have to know if the thing is, if it is a provider or consumer of my data. For that, we use what we call DXIDL, which is Data Exchange Interface Description. It's a JSON file. It's a configuration file that we use. And we say this thing is IoT device or system. It's a provider or consumer. It's a one-way interaction, two-way, and so on. So it's a very simple configuration file where we put the interface description. Here, in this case, it's a provider, for instance. Operation, it's a one-way. The scope, it's post traffic here. It's just an example. For example, for MQTT, this is the topic. Or if it is a client server, this is the resource that I have to use. Then I have the data that I have to provide. In this case, it's simple string, so it's speed, longitude, latitude. Here is a workflow, what I have to provide as an input for my mediator, for my manager, in order to give me the adapter automatically. So I have to provide the XIDL file with the specific parameters, like it is a provider, one-way, traffic info, and also the data. Here I'm also giving the protocol. The protocol, it will be used later on. At the beginning, I use just if it is client server or the type of interaction, client server or publish subscribe and so on. Then I provide the common protocol. So I want to go from MQTT to CoAP in this case. So this is the input. I give them to the DEX manager. Then the DEX manager will generate for me a generic mediator, generic without a real implementation. Just it is a generic mediator, an abstracted entity, let's say. Here we have the one-way, the APIs that we saw already, the post and get. And here also we have on the other side the post and get primitives. So once I have a generic mediator with what I need as abstracted methods, I can create my real instance. So I use what we call a protocol pool. These are the functions, the real ones, the implementation of the functions. So I take what I need from here, and then I generate the concrete mediators with the two protocols that I specified at the beginning. So MQTT to CoAP, they are here, and I took the functions from this. Here is an example just to make it easy for you. So as an input, as I said, I have just to provide the DXIDL file for the two entities. Here is a car, for instance, that use publish subscribe. It just published the data using MQTT. So I use MQTT. It's a publish subscribe. This is very important, publish subscribe. Then I have, it is a provider. It's a one-way interaction. I just need to send the data. On the other side, I have the service that will receive this data. So it uses WebSocket, a data stream. So here we have data stream, and here is publish subscribe, totally different. Here it's a consumer, and also it's a one-way interaction. It means that I just receive the data from any server or provider. So what the mediator will do once I give him these files, it will generate the generic mediators. Two mediators in this case. Mediator one with here is CS, it's client server without CoAP for the moment. And the second mediator. Remember the ESB paradigm. We have two mediators and the common protocol in the middle. This is what I have here. This is the first connector. So I have publish subscribe to client server, and this is what I need as a client here. What I need is I have to get this data. Then we have the exclusive get, and to end XM get is to terminate the reception of the data. Then I have the second connector of the mediator, which is where I will use one primitive in this case, is post. It means that I will expose this data. I will receive it here as MQTT, using MQTT, and expose it here as a server. Then the third connector here is the client. So I should receive, because we're talking about client server. So here I have a server. Here I will have a client. So I should receive here the data using the client server, and these are the primitives. The primitives are the abstracted ones that I showed already. Then here the final connector from client server to data stream, and this is the post. And finally, I will use the two inputs that I have provided at the beginning, means MQTT WebSocket. Click on the pool, I get the functions, then I will generate my concrete two mediators. This is the idea, and of course, using DexMS, we use just lightweight mediators because they are very lightweight. We don't use any useless function. Let's say I just put what I just need. The portability, because we use Java. So basically, we need just a Java virtual machine to run it everywhere. We are talking about edge components and sites, so we don't know which architecture we have there. Also, we can use any common protocol. So it's up to the app developer. He can choose as common protocol, CoAP, HTTP. It's up to him. The mediators, they are employed only when necessary, of course. Like in this case, I have here MQTT to CoAP. The bus protocol is CoAP here. Then here WebSocket to CoAP. Then I have the traffic light. Traffic lights in this case use CoAP, so I don't need any mediator. It will be part of my bus protocol. And it supports any protocol classified under CS, PS, DS, or TS. Even if I have a new protocol, an emergent new protocol, I am sure that it will be supported by DexMS, because it is basically it will be one of those communication styles. By doing some experiments, the results showed that we can save up to 96% of the development efforts. Here we compare the line of codes if we use the mediator or without. Then, of course, we have the evolution support. We can add basically easily new services to the bus. This is very easy. And also, what I will present later on is about the infrastructure, so how I can deploy this mediator, I don't know, at the edge of the network. This is not an easy task. And also, we have to manage the connectivity. This could be, I don't know, a mediator in São Paulo, this one in Paris, and they should communicate among each other. So this is what I present right now, and we use for that OpenStack. So we have integration between OpenStack and DexMS. OpenStack, as I said, okay, the mediators can be deployed everywhere, and OpenStack, it's a very well-known cloud operating system, cloud platform that we use. It's open source, and it's the second biggest open source project behind Linux. It is used for infrastructure as a service clouds. And what we need from OpenStack basically is the reachability of mediators. I have to deploy my mediator, I don't know where, but I should be able to do that. So we use basically two systems from OpenStack, Iotronic. I have been working on that project for a couple of years now. Then we use also the official project for the networking, which is called Neutron. I will focus only on Iotronic and Neutron. We have other, let's say, integration with other systems, but I will not talk about this in this presentation. So Iotronic, it's a cloud OpenStack compatible system. This is an overview of Iotronic. We have on the cloud, we have the Iotronic subsystem. It can communicate with other OpenStack services like Keys, Ignite, and so on. We have our command line that we can use to interact with the system. And on the edge side or the IoT device, we have our agent, which is called Lightning Rod. So Lightning Rod connects to Iotronic to a set of channels, WebSocket-based ones, because they provide a full duplex permanent communication channel. We can then send the remote procedure goals to do something on these edge devices. And this is how it works. Basically, we can also be sure about the NAT traversal, because we could have IoT devices behind NAT, behind the network address translators, and this is not easy to deal with that. So Iotronic, we use it to do that basically. Then we extended Neutron features. So Neutron, as I said, is the networking subsystem of OpenStack. It provides for the users the ability to create virtual networks or overlays between VMs, containers, bare metal servers, but I'm talking just about the cloud, so it doesn't go beyond the cloud. What we have done is an extension of Neutron. So instead of creating overlays only between VMs located in a data center, I can just take my Raspberry Pi, for instance, and do something on it. Iotronic will do it. Then it will be connected to the instances on the cloud. So I can have the Raspberry Pi communicating with a VM on an OpenStack data center. So this is what we have done. I will not go more into detail. So we have, what we did is just like we emulate the hypervisor role. So the hypervisor in the case of VMs, for instance, it creates a kernel interface. It's called TAP interface, a TAP networking interface, and it gets connected here to the virtual switch. So this is the role of the hypervisor. So what we did is we emulate this, and I will create the TAP interface connected to the Linux bridge or OpenV switch that I have on the cloud. Then I will use a WebSocket tunnel here in green that will be connected to a virtual interface that I create on the edge side. So this is what we did. It's an emulation of the hypervisor role. And I would like to mention that on the edge nodes, we don't have any subsystem related to Neutron. So this is very lean for the edge nodes. They are not even aware about Neutron, if it exists or not. Then these are some of the use cases we can achieve with this solution. Of course, for instance, we can have two networks separated. And I would like to mention that we don't use any VPN. We don't use layer 2 or layer 3 VPNs here. So they can be connected within a same overlay. Then they can communicate here. For example, I can have this mediator communicate with this one in order to exchange data between different protocols. Then we can have two networks, separated networks. Then the cloud. As I said, we can have VMs and edge nodes within the same overlay. As we can see here, they can communicate, of course. Then the third use case, which is very nice, is the mobility. So even if I have a mobile IoT device, which means it can change of IP address, of private IP address, it may stay on the same overlay even if I change of connectivity option. I can pass from Wi-Fi to 3G, but still I will be on the same overlay even if I'm moving. So this is very important for dynamic scenarios. And as I said, we don't use any layer 3 or layer 2 VPNs. So for the research directions, we would like to make more automation for creating our mediators. And we would like to rely on semantic models like ontology-based in order to generate the DIX IDL files that I have described a few moments ago. So we can use, for instance, NLP for that. Then we would like also to automate the protocol abstractions, because for the time being, it's like manually we have to develop the functions that do the translation. Then we would like also to extend the networking features using, for example, TCP, UDP, whole pension, because for the time being, we are using the virtual switch, if you remember this one. So we are always using this switch here. So the idea is to bypass the switch and use just direct communication channels using TCP or UDP whole pension. And also, we would like to extend the XMS features and to go beyond IoT dimension, and we go to, for instance, the serverless platforms using multi-cloud, to use the XMS for multi-cloud serverless environments. It means that I can use Lambda from AWS, for instance, and I can just create a workflow between a Google Cloud function, AWS, and Microsoft Azure. So this is very important. It can reduce the prices too much, and it's a very nice topic. And we have even a PhD student that he just started a couple of months ago. He's working on that specific. So this is the project is open source, of course. It can be downloadable from our repositories here. These are some of the references that I used for the talk of today. And have any? Yes. Yes. Okay. Okay, so as I said, this is the workflow that as an app developer I can use. I have just to fill in a JSON file. On that JSON file, I have to specify the protocol. In case I use, for instance, MQTT. Then I use the description. So I know that this car, for instance, it's a provider, so it will always send data. This is it's the type of interaction. It's a one-way interaction. This is the scope, which is the topic. So this is the topic for MQTT, and this is the data they will send. Then I have the common protocol. If you remember, I was presenting the ESB, so I have a common protocol in the middle that I will use for the interconnection. Sorry? No, you can choose whatever you want. No, you can choose. So it's up to you. You can choose the protocol you want. No, you don't. You just provide the dictionary. So by providing just this file, of course, for both sides. No. This is what we are trying to do, like to automatize the creation of, let's say, if I have a new protocol, or I just want it to be part of my protocol pool here, I can use like some machine learning or something automatically. So as I said, this is manually done for the time being. So we have the pool, we have MQTT, CoAP, HTTP. We have like 6 or 7 protocols. But if we need more, we have to do it by hand. Yes? Okay, so here I was talking about edge in the sense of fog and edge. Yes, both. Yeah. So to deploy the mediator, you can use, we use that system from OpenStack, so you can deploy it everywhere. Up to you to choose. And I didn't talk about the quality of service, because this is where your question more related. Sure, because I said on that slide I will not tackle quality of service. We have a couple of works related to that topic, like for queuing, for instance. I have a lot of packets. What should I do? I forward first or last? So this is the quality of service. We have also that aspect, but I didn't mention that. It's here. So we have also done some evaluation so that we respect the quality of service. You mean if you have a device from, Amazon, for instance? Yes, once. Yeah. So you can just use their SDK just to reprogram or program the IoT device. You give the IP address of our middleware manager. You send the data, and he will do it for you. And yes. You mean the project? And this is what we are trying to do. Wow, yeah. Yes. do something. Protocols. But I don't know how you can do it. I mean, building the machine learning, I mean, an AI intelligence that do that will be based on that. This is the cornerstone, I would say. This kind of, I mean, thinking. That we are trying to do, yes. But it will be based on that. Too complex for it. Thank you so much.
Yes. Okay. But I'll talk now more about the work that I have been doing the past 5 years, which came from a very technical middleware part, but then starting to apply it to real problems. And then data science came into play, and artificial intelligence and machine learning, added to all the middleware and systems thing that we used to do. And we applied computer science to these real problems in cities, and then we started to get some solutions, and then we started to talk to politicians and city managers to actually put those solutions to practice. And then each time it goes to a more applied layer, things get more complicated and out of the hands of our scientific world. And I'll talk about a little bit about all of these things we have been doing the past 5 years around that. So I'm coordinating a very large project on smart cities that's actually ending in the end of this year. So it's a 6-year project, and this is the last year. So we were about 100 researchers and students throughout Brazil. This is part of Brazil, but the main host was this institute here, the Institute of Mathematics and Statistics in the Department of Computer Science, USP, but you can see that there are other institutions in Brazil affiliated with us. And the goal of the project was to, first, as a project funded by FAPESP and the Brazilian agencies, it was one of the major goals to produce scientific publications and publish in journals and top conferences. But we also have a major emphasis on producing open source software that could be used by either governments or other researchers or startups, for example, and on releasing the data sets that we were able to collect, and to try to do some technology transfer to governments. And this is our website. First of all, so I thought, I said that we worked with smart cities. What is not a smart city for us? So a city full of technology everywhere is not a smart city for us. A city full of robots, autonomous vehicles, a city with high-speed 5G everywhere, a city full of cameras with government spying on everyone, as we see in some countries, and with companies spying on everyone where we see what we see in the other companies, or other countries, I mean. So for this scenario is a definition of a stupid city for us. So we don't work in this realm. What's a smart city in our project? A city with happy, healthy people, with very few cars, with lots of pedestrians and bicycles, moving around green areas, parks, places that are enjoyable to live, with people participating in the decisions of the city, and with the public policies of the city being based on scientific evidence. So this is a smart city for us, and we work towards this. I know cities that have some good initiatives in all these topics, but I don't see yet an ideal, perfect city. And I probably never see, but I think this is a direction which we should move towards. Because a lot of the people have the direction, the image, this, and I don't think we should move towards this. We should avoid this. I think we should try to move towards. And this is what we try to do. And the really good news for us is that there's a lot of work in computer science that we can do to help achieve that. So in particular in our project, we have researchers in the fields of HPC, big data, data science, interactive visualization, machine learning, and middleware systems. That works towards that. And I'll show a few examples of the projects that we have developed in the past years. And again, so that was our view of smart cities. And our focus is not on building new perfect cities in the middle of the desert. It's also not on making Paris smart, the central Paris is smarter than it is, because Paris for me is already perfect. I'm working on making this better. And this is the city where you are now. This is São Paulo, where you have at least half of the population living in very bad conditions. So this is São Paulo. We are around here. And this is where the rich people live, the middle class, and this is where the poor people live. And so I want to improve the lives of these people here. So a lot of our projects deal with problems that face these scenarios. And I won't tell much about theory. I'll show through the projects that we developed the kind of approaches that we have. Okay, so the first one that is very, middleware related, connected to the presentation we did before, was that we developed a software platform for developing smart city applications. We started by going to a few cities and seeing how their IT systems work. And the first thing we saw is that each secretariat, for example, in São Paulo, had complete separate, isolated silos that didn't talk to themselves, and they reinvented the wheel. So the Secretary of Education built their stack of things, and the Secretary of Health built several different stacks that were not connected, and so on. So the first thing we, as middleware researchers, did was to develop a generic middleware platform for developing smart city applications. And the idea is that an ideal city would have such a platform and to share data and databases of the city itself, and you would build the applications on top of that. So we built this open source middleware for doing that. And we have used that in multiple courses at universities. So we teach like a smart city systems development course and the undergraduate and graduate courses here in the University of São Paulo and in other universities in Brazil using this platform. And we also do some hackathons in which we lock some young developers in a room for 24 hours, feed them with pizza, and they produce some nice prototypes. So for example, this is a prototype of a smart parking application for São Paulo, built on top of the platform. This is another group that created an application, an app that tells you in real time where is a good place to do some specific kind of sports outdoors. So you said, I want to go cycling, and then it shows where is good or is bad to do cycling, and the same thing with running, for example, based on lots of data collected in real time, like air pollution, humidity, temperature, UV indexes, and the software knows the city, so we can provide suggestions. We were doing like these toy applications. We did a lot of them, but it was interesting when the COVID crisis arose, the state of São Paulo built a situation room to manage the pandemic in the state of São Paulo. The state of São Paulo is 40 million people. Less than France, I guess. Almost France, yes. Yeah. And this is a real picture of the governor office there. And the nice thing is that they used our platform to collect data from multiple sources, from about people moving in the city. So traffic counters, speed traffic counters, automatic vehicle identification, public health systems, point of sale hardware, smartphones, etc. And could do a lot of real-time visual identification of this data, and that helped the public health officials that were deciding how to manage the COVID crisis. And the state of São Paulo, I would say it was very professionally and scientifically based done. It was very different from the federal government, and that's terrible in all aspects. So we were very happy to see our code being used there. Okay, that was my first example. The second example, in Brazil, we have a lot of open public data about health and education. And in the case of health, for example, we have the public national health care that serves more than 100 million people in the country. And we have data about everything that happens with these people, anonymized data. And the data is almost not used for modern data science. It's used mostly for administrative issues, for paying the transfer of money between governmental agencies. And we actually got this data and created a set of interactive visual dashboards for public managers to think and reflect about public health issues. So this is showing, for example, in São Paulo, the 60 public hospitals we have here, and how long does it take for the patients to go from their house to get an admission in the hospital, according to medical specialties. So you can see that some medical specialties have a lot of people that need to go a long way within the city, like 20 kilometers to be hospitalized, which shows that there are some areas that don't have enough coverage. And it's an interactive tool that actually shows what the areas that are not well covered. And you can do this kind of queries according to different aspects, like different diseases, see how is the distribution of diseases. And here we have 3 examples of dengue fever, HIV, and leukemia that have completely different distributions in the city because of the social, demographics, environmental aspects of the city. So this is something that before the health officials wanted to look at these things, but it took like 1 month of work to produce such a graph. And now with our system, it takes like 5 seconds to create such a graph. So they can very quickly reflect on the problems. And these are like the same tool you can use to analyze different kinds of hospitals to see where are coming the patients from a specific hospital. So this is a hospital from the University of São Paulo that gets patients from all the city, and this is a very regional hospital that serves the patients of this very small region, for example. And how the diseases are spread. This is hypertension is the most frequent cause of hospitalization in São Paulo. This is where the people live that need to move more than 20 kilometers within the city. It can take a long time in public transportation, like almost 2 hours, to get to a hospital, to get hospital service. So these are the areas that are not well served by hospitals. Okay, so, and this is under evaluation by the city. We see a big problem we always see is that the low-level employees, they really want this kind of technology because they see a lot of value in this. And actually, we developed together with them. They were providing the requirements and the design directions, and we were developing together with them. But the higher level management and when you get to the politics, it's very difficult to convince them that they should invest in science and proper tools. This is a challenge. This is another example where you can use, for example, data from Google Street View to analyze the green areas in a city such as São Paulo. So this uses AI to identify the green in one picture, but when can feed the system with like billions of pictures of the city, and then it can draw, for example, heat maps of the green areas and showing in red the areas that don't have greenery. And so the city has investments in making some parts greener. This is a tool that could help them to guide where to make these investments. This is another application, using also machine learning to detect where there are trees entangled with electric wires. So this could help like the electricity company to decide where to prune the trees in the city. This is another application in which it can show areas in which new trees were planted, areas in which trees were removed, sometimes legally, sometimes illegally. Areas where nothing changed, and areas where the trees were pruned. So you can, by analyzing hundreds of thousands of pictures, draw a map of this in the entire city. So it's a powerful tool for cities also. And then the area in which we are focusing more, which is mobility. So the 20th century was a century of the car, which is great because it provides us awesome flexibility when can go very fast most of the times to wherever we want. But it produced it's terrible because it produced air pollution, noise. It kills thousands and thousands of people every year in Brazil. It uses a lot of space, not only the space of the car, but the space of the avenues, the space, the parking space. 1/3 of the land of São Paulo is parking space. So if we can get rid of the cars, we get 1/3 new São Paulo, or as a present. So transform most big cities in an awful place for humans. The cities that have more cars, it has less quality of life. And the urban planners in the 21st century, they say that the cities of the future should focus first on non-motorized transportation. So ideally, you should be able to go to work and school, etc., by walking or by bicycles. The second alternative should be a good public transport system with buses and trains and subways. And a third option, and very low, should be electric cars and probably in the future autonomous electric cars. So you should have a lot of that, many of that, and few of these in the future. That would be our ideal city. And we are working to promote the first two. We did a little bit of work on this, but we are focusing on this too. So we have a spin-off spin-off company, a startup that came out of our research group that's called Cipopolis, that they created an app for public transportation by bus. Bus is the main mode of transportation in the city of São Paulo. São Paulo, there are 15,000 buses because the subway is not as good as in Paris, for example. And this app uses a lot of AI to predict the times in which the buses will arrive, and once the bus arrives, how much time it will take to reach each of the location. And normally a person has a choice of several different buses, and based on this information can make different decisions. And you need a lot of AI and a lot of data to do this in São Paulo because the traffic is completely chaotic, so it's very difficult to predict the time the bus will need to arrive and also how long it will take, different from a smaller, more controlled city in which you have a timetable of buses. Here, the timetable is fiction. And they also developed a real-time dashboard for the city managers that they manage, in this case, to sell to the city of São Paulo. And it's a real-time dashboard that manages these 15K buses, showing alarms and triggers and whistles and lights to the city, to the people that operate the bus system. And it was nice to see that this was actually used and tested in several cities. But again, it's very difficult. The technicians that deal with the system see that this is extremely useful and help their work a lot. But the top layers and the politicians don't care about this. Just think about the next election. And that doesn't necessarily help them the next election. Okay, so this is on public transportation buses. And we have been also doing a lot of effort in applying data science techniques to improve non-motorized mobility, walking and cycling, but mostly cycling. So we developed an open source package that, given the trips that are done, for example, in bicycles in a city, and this data can come from different sources, can come from, for example, bike sharing companies that have these bikes that you can rent, or also from large surveys that some of the cities do. São Paulo does a large survey with 250,000 people every 10 years. And then you can plug, and it shows you where are the major flows of cycling mobility within your city. And then you can plot the major flows against the existing cycling infrastructure. And this already gives a hint for the public policymaker where you should build new cycling infrastructure. So for example, this area here is a big flow that's well covered by cycling infrastructure, but this one here, all this part doesn't have any cycling infrastructure, so it should be nice to have a bike lane here, for example. This is by visual inspection. Then we are trying to automate that. What we did is to create this São Paulo Cyclability Index. First, we interviewed 200 people that don't use bicycles but would like to, about how they feel that a certain route, this route, for example, is cyclable or not. So we wanted to ask mostly to people that don't bike, because the people that bike, they already bike, and some of them are radical bikers, that anything is cyclable for them. So we focused on people that don't cycle. And we show the distance, the slope. The color here are the slopes, and tell how, on a range from 1 to 5, how cyclable is this thing. And then we interviewed 200 people, each of them rated 5 routes. So we had about 1,000 routes that were rated, and based on that, we created a model of what a Paulista person, a people that live in São Paulo and then doesn't use bike, thinks that it's cyclable. Then we got all the trips that are done in São Paulo. Every day in São Paulo are done, 40 million trips are done. And we got the route of these 14 million trips and analyzed each of these 40 million trips according to the cyclability index to detect what is cyclable, what is not cyclable. And then later we drew these routes on the map. So the red are routes that are highly cyclable. And what we found out, right now we have about, from these 40 million, about 225,000 are made by bicycles. It's something between 0.5% and 1%. A little more than 0.5%. But according to our model, there are 7 million trips that are, which is 15% of the total, that are very easily cyclable. And in particular, if you look only at the car trips, there are 1,700,000 car trips that are very easily cyclable. 14% of the car trips. So this means that you can multiply by 20 the number of people that cycle in the city of São Paulo if you have a good cycling infrastructure. They don't cycle because they don't feel safe, because they have to share the road with the cars, or maybe the area is not very safe. So if you had a good cycling infrastructure, then you could easily multiply by 20 the number of people that would cycle, and that would have a huge effect on air pollution, the health of these people, decreasing the traffic. It would be better for everyone. And then we did a software that shows to the city government where are the areas in which there is no cycling infrastructure and there is a high demand for cycling, which are these red areas here. And these are basically the areas in which the city should build the cycling infrastructure. So here there should be a cycling path, here, here, here. And the city also actually has some budget for doing that every year for the next 10 years. But the budget is invested like, the decision is made manually. The technicians, they open a map of the city and say, I think this would be good. And the others say, no, maybe not. This is not good. But here we're showing data is evidence, scientific evidence based on data. It doesn't mean that they must create here, but at least it's pointing out that this is should be a top priority, and then the experts in the field should look if this is feasible or not. But at least it's showing, pointing to the places where they should invest. And then to end my presentation, we have this ongoing project, which I like very much, which is the Bike SP. It's a partnership, another partnership with the city of São Paulo. And I like it because we are designing a new public policy to foster the use of cycling as a transportation mode in the city. And the thing is that 5 years ago, the city approved a law saying that it would pay citizens to use bicycle instead of car. But the city had no idea of how to implement this law, what the parameters should. So the law was approved and ignored for 5 years. And then the city asked us, can you make a case for us a way of implementing this law that's based on science and data, and then we'll have a chance to actually implement it. And so we are doing, said we'll try, and we are working on that. And so there are basically two research questions. What's the cost of such a program? Who would pay, and how to pay the people in order for it to work? And what are the benefits? Benefits for the city, benefits for the citizens that receive this. So we are doing the data science part, but we also have economists helping us. So it's a very interdisciplinary group of people that are working. So people from computer science, data science, cycling movement, and economists. They are working together. And we are taking a scientific approach. So we are carefully now designing an experiment with real citizens. We are going to pay for 200 citizens we are going to pay money for them to cycle, to leave their car in the garage and cycle. But we are doing that we are designing the experiment in a randomized way. So we are paying different values for different people and getting in our random collection of people different genders, different ages, different socioeconomic levels, and so on. So we'll have this randomized pilot experiment, and then with lots of data science, and also with help of economists, the economic analysis, we are going to propose a plan to implement this law in the city of São Paulo. And we'll do this in this year, and hopefully, in the ideal world, we'll have the plan delivered to the city for the next year. Okay, so this is it. And just to end, a new thing that we are talking about as in our research group is that we would like to have a new project on software engineering for AI and machine learning systems. Because in the real world, if you have big companies or governments using machine learning in their production environments, you see that the machine learning code is a small part of the code. A lot of the code that you need, probably 90% of the code that you need, is not the machine learning code that will actually run the model. It's everything else. And how to organize all these components and how to have a software development process that's effective for this environment is a big challenge. And so we already have one PhD and one master student that are starting now in this topic, but it's a topic we would like to invest more in the future. So it's a potential topic for collaboration with IA. Okay, so I'm finishing here. Thanks. Any question or remark? No, a bike takes, 8 bikes take the same space of a car. So if you, but that's we want many more people using the bike and less people using the cars. Yes. You mean, okay. Yes, that's part. Yeah. That's why we are doing a pilot program and to design a program that tries to maximize people leaving the car and going to the bike and not other ways, for example. So for example, what would be more common, I think, is people leaving the public transport to use the bike, and that doesn't necessarily is the best thing. Maybe it's a little has a little good effect, but has negative effects also. So we want to maximize the positive effects. That's why we are carefully doing these experiments and designing the program. But you're right on that concern. At a hypertension, for sure. Well, there are lots of scientific studies that show that you save a lot of money in the health system if you have people cycling, because the health of the people will be better. Yeah. And also, the pollution kills 20,000 people in São Paulo per year. If you can decrease 10% of the pollution, you're already saving maybe 1,000 lives. We'll have people that will try to quantify that. Yes. Legacy codes. Badly written Python code. Yes. 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 Good software design practices. Yes. No, I think it's included. It's something. Our group has a long tradition of doing that, but not for ML code, for other kinds of code. So it would be natural to apply that to ML code. Yes. Yeah, but that's a good point to remember that inside this box there's a lot to be done also. Yes. No, Yes. Yeah, we take we saw that the major components are the distance and the inclinations, but just after that is the gender and the age. So when we say that's very easily cyclable, we are looking at the age of the person and to the gender, because men can bike a little more and use a little more, feel more comfortable with a little more inclination. So we are taking all these things into consideration. Because we have in this big survey with 250,000 respondents, we know the age and the gender and the route and the socioeconomic level of the income. Oh yeah, yes. Mm-hmm. So what I can say about this slide, the dengue fever is highly related to the area in which you have forests in São Paulo, because the forests, they have the mosquitoes and they bite the people, so you have more dengue. The HIV, the topic, the focus is here, where you have a lot of drug addicts and people with. And for leukemia, I don't know, but it shows a big spot here. So I just put there because that's a question, but I cannot answer. Is the health officials that should answer. Is there any reason for having a leukemia problem in that area? Maybe not, but maybe yes. So the idea is that the tool just points something, and then the expert should analyze, and maybe it's something, maybe it's not. Maybe it's just an artifact of the data. Yeah. Yeah. I will say that this tool at this point, it doesn't provide answers, but it provides guidelines for, or a direction for the expert to look at the data. And it's a very easy way of looking at the data, because this data is millions of records. So either you give a 1 million line Excel file, or you show this way. This way you can see much more things. Mm-hmm. Yeah. Localized. Yes. Mm-hmm. Okay. Thank you. Let's see if it works.
Issues that have been just discussed about model machine learning for the environment learning. So this is joint work with the group of Fabio Porto at LNCC in the context of Inria Association. We have been working on couple of years. So our background is data science and management. And here we have applications that motivated to deal with model management in a way relatively similar to the way we deal with data, because data management is well established. So the motivation is that we work in the context of applications related to environmental science, life science. So maybe not previous applications, although I'm not sure. So for example, take climate change. In the context of life science, as you may know, in Montpellier, there's a lot of people working on plant biology and so on. And the real issue is how could we select and breed new plant varieties that will, in the future, resist climate change. In the state of Rio de Janeiro, they are interested in extreme events. So sometimes for a short period of time, there are heavy rainfalls, which create lots of problems, and so on. And so how can we predict heavy rainfalls in the region? Even though we don't have all the data, but we have data, for example, in a region that is similar, which means we may want to be able to reuse models which were not done for a particular. So, but in all the motivations, we see a big need for modeling. So we had a lot of talks about modeling today to predict impact. Really, prediction, which is important, and we need to do that based on the data. You know, prediction without the right data doesn't help. And well, we've seen that in the COVID-19 presentation. So, and what's hard is that we have to deal with heterogeneous multimodal data, depending on the application. I will zoom on some examples. So, for example, we want to deal with individuals or group of interest, so groups of plants, of birds, of trees, maps, regions, sea, mountains, depending, environmental data, meteo, which could be real-time data, soil, rainfalls, as well as, this was the discussion in the COVID, social data. What about populations, cities, suburbs, as you mentioned, rich versus poorest neighborhoods and so on. These are very important. So lots of data, but very heterogeneous with very specific features. So in Montpellier, we have been working a lot with, in my group, for example, 30-people group. We have researchers from CIRAD as well, so they are working on plant biology and plant modeling. And what's really critical is that you have this issue of multi-scale. So you want to study plants at different scales. So the micro scales up to the field or the region, and also at the individual level. You want to learn what's happening with a plant, a tree, or whatever. Data acquisition, you have all kinds of platforms. You can have drones, you can have, for example, in Montpellier, you have phenotyping, plant phenotyping platform that deal with thousands of individuals of the same plant type. And you have tools with sensors and so on. And then you have models. You have mathematical models, you have machine learning models, as well as simulation models. I make a difference, but it's not really important at this point. And where are the data? Well, the data comes, so you have a lot of data online, international databases, for example, genomics, soil data, climate data, and phenomics. You have images, 3D point cloud, for example.
But you have also all the data which are produced by the models, essentially time series with sensors, or 3D. 3D data are very important. So people are thinking about multi-scale frameworks in the context of crop modeling. So this is very interesting work. It's a Nature Plants recent publication. So I'm not going to go into all the details, but basically we are going from small to large scale. So for example, here, we want to study the individual, the plants, from the gene to cell scale. So we have high throughput genotyping platforms. At the organ to field scale, you have a high throughput phenotyping platform. And then you have a regional to global scale. So crowdsourcing, remote crowdsourcing is used in the PlantNet application in my group, remote sensing, etc. So this is a multi-scale crop modeling framework where typically you want to do things where you study all these objects, these plants, at various levels of abstraction from the gene. So for example, very important today, relating genotypes to phenotypes. Actually, this was done very separately, working on the organs, and then on the regional to country scale, global scale. So an interesting project is called AGMIP. It's managed by the Columbia University in New York with many people. And the goal is to develop simulation crop models to analyze and predict plant and crop development from molecular to ecosystem levels. Have the different levels here, the different objectives, and the different kinds of models. And who are the modelers? What's very complicated, I don't know anything about modeling, by the way, in this area. But you have to talk with different people. And so, for example, at this level, you have the biologists. But at this level, you have the crop modelers. And then you have the ecosystem modelers. They use completely different models and techniques and so on. And what's very interesting is, based on that, well, you can implement the model. So, for example, using a workflow, and they produce different models. So, for example, in the context of wheat, there are more than 40 different models in use. And so there's not a single model. Right? There are different models for different kind of wheat, or rice is even worse, hundreds, because in Montpellier I work on wheat, on corn and rice, well, everything that feeds population. And people want to use the best models that best fit a particular situation, a region, for example. And they try to also combine to hybridize those. So that's for Montpellier. I'm showing, this is from Fabio's work here with the state of Rio de Janeiro. So they deal with multimodal data, and the timing is very important, of course. So you may have weather forecasting here from 4 to 5 days, but the rainfall's 2-3 hours. And also here you may have 12 hours. So you have to deal with different time windows. Okay, so since you have to deal with models in general, for machine learning models, which have been discussed quite a bit today, you have this life cycle. So in fact, Fabio was talking about something more general than just the machine learning. There's a whole life cycle. So you start with data sets, and there's a whole pre-processing. This is very important because if the data is buggy, dirty, and so on, you don't do much. So there's a lot of processing. So in data science, this is a whole field of data cleaning. And then there is a training. So the training is really what you usually think of when we talk about machine learning, when we train based on the data we build and test models, validate, so we have multiple models. Then you can deploy the models. So deploy the best performing model, best meaning on some criteria. And then there is the prediction, because in our case, we are interested in prediction, so you can have predictive queries. And you can also introduce new data. So for example, with the rain, the extreme events, what will be important is the new data coming online from the rainfall prevision. So one issue that we have been dealing with in this project is that, in fact, what's happening for a big problem is that people produce different models using different environments. And they may use scikit-learn, PyTorch, whatever. And then they produce model ensembles. And you will see that there is a technique to deal with model ensembles. And there are things like transfer learning, model import, and so on that are important. So this produces a model version, which can be stored and managed centrally. So I'm really talking about model engineering. And then there's the use of the models. So the deployment that you may want to deploy a model done for another platform, for another environment. You may even want to do model composition. And also you may want to update the models. So this is really the big picture and the context in which we are working on. And so the objective of this JACY system is to make, we prefer to talk about artifacts than data or models, because there are many more things, metadata. So data sets, models, versions, even software. The versions are artifacts that and we want to make them easy to search and manipulate for the scientist. Well, we have also different categories of users, scientists, data providers, and so on, model providers. And with that, we want to be able to collect, curate, and integrate heterogeneous data. So that's the whole problem that the whole data science community have been working on, and still accurate. We want to support the complete model life cycle. So from model building to deployment to monitoring to policy enforcement, there are various states. And I think this is really the main contribution of what's behind it, is to make it easy to find ready-to-use models that best fit a particular prediction model. So if you are in a new situation, new region, for example, you want to do something, there's no model, you may want to try to find a model that have been working well in some other area. Of course, the deployment needs to be done with various tools, because think of a big problem, there will be many people, each group of people with a particular machine learning tool. In my group, for example, there's a PyTorch people, there's a Google people, and there's also scikit-learn. So workflow management systems. For example, in plant biology, we typically have JACY for the phenotyping data, and OpenArea, which is done by Inria and Sirad, for the phenotyping data. Well, a big data science platform, of course, is Spark from Berkeley. And we also want to deal with something we've been working on for a long time, which is deal with data provenance and prediction explainability.
and we want to be able to repeat experiments and stuff like that. This is the 30-second ad session. So we want to use easy-to-use web interfaces, an open architecture, so state-of-the-art in application engineering, well-defined APIs, foster services interoperability, a little bit like in the middleware. What we do is not really a middleware, it's higher level, but we want to rely on platforms like ones that you discussed before. If, for example, we have IoT. And all this needs to scale. We have lots of data. Number of models may not be an issue, but the data is an issue. And the only scalable architecture that I know is a distributed architecture. And it fits very well in the cloud. So we rely on distributed database techniques. That still need to be improved, but we rely a lot on that. Okay, so the design choices for the JACY system is to do an open platform that can be implemented as, for example, because we want to have various implementation, as a platform as a service in the public or private cloud, because depending on the, for example, with Inria, which is one of the main partners, they prefer to use a private cloud, a hybrid of a grid platform. We use a lot shared nothing clusters because it works very well. We use a previous project that we've done in this associated team called SEVIMI. I will say a few words. It's an array database. So basically, it's a database system that manages very well the array data structure, which is used a lot in scientific applications. And we want to provide integrated services on top of various distributed databases, various tools, and so on. So basically, we want to be agnostic to a specific tool. Okay, so that's the JACY system. So what does it do? It relies on SEVIMI. I will discuss SEVIMI for data management. So everything which has to do with registration, transformation, meta description. So you may want to register different models, but data sets and so on. It exploits data locality for transformation and training. And because it's the database, it has a nice facility that it's easy to know what is in there, because you can write high-level queries. You don't have to write Python code to know. That's a primary principle in data science. In terms of model management, it provides help to do model building, importing, and serving. I will describe this, I think, yes, the ensemble method, which is a previous contribution for automatic model composition, and also it provides for model metrics management. I forgot what this is, so I'm not sure I will describe in details, but it provides support for event detection, and of course multiple execution environment. For example, there are, we use the Santos Dumont supercomputer at LNCC or Spark clusters at Inria, and we want to be able to use those simulating systems. Okay, so the DG ensemble is something very interesting that has been published recently, especially at this SSDBM, statistical and whatever database management. So it's a cost-based selection and allocation method for a digit ensemble of spatial temporal models. So well, I'll give a little bit of details. It partitions large data domain into subdomains according to data similarity. So for example, if you have time series data, it will place similar series together. So the idea is, and I'd like to have the feedback on that, instead of trying to have a single best model covering different patterns, we have more specialized models. And if needed, we may be able to combine them. So if you have different regions, you may want to combine model 1 with model 2, and this will give you the composed model. So this is very similar to model engineering, MDA, whatever. And in the papers, there's an algorithm to do that automatically. So the decision on which models to combine, this is a very important one because this is taken at runtime to answer a predictive query. It's based on data similarity between the query region and the model training regions that has been used to train the model. And there's a learning function which expresses the generalization capability based on prediction error. 2 phases, an offline phase which does this domain partitioning and compute representatives of regions, and the online, which uses the SAVIMI database system. So this gives us a pretty interesting architecture where, well, basically, we can interface with world of machine learning system with some, well, I'm not a big fan of Jupyter. I prefer real web applications, but or dashboards if you want. But this was initially what was done. We can also get streaming data, so we have tools to deal with this. And the heart of the system is a JACY core with some functionality to deal with the data and to connect with SAVIMI and the external system. We also use a workflow platform called Dask. This I will not talk because I'm not sure what's been done, but the idea is that this could be used to do a digital twin server. And this is very interesting when you want to test, for example, with a real system with a twin. So SAVIMI has been there for a while. It means simulation analysis and visualization in memory. So it allows to do simulation real-time monitoring. It deals with space-time multidimensional nature of all phenomena. Initially, we used it for astronomy applications. It has some nice feature, but it's basically a multidimensional array data model, like SciDB. SciDB is a famous system, but a bit old. What's interesting is that it has a distributed architecture with what we call in-memory, in-transit architecture. So if you have several systems, so for example, you have an application, simulation application running on an HPC platform that produces data. You want to analyze this data on another server. We can do it in memory while the data is produced. So that's a big feature. And it's, well, this is something else. And this is also a pretty good publication. So it's been deployed, for example, at LNCC using a cluster called Petrus for doing the analytics. And basically, the Santos Dumont supercomputer is used to do the simulation work. So basically here, all the access are in DMA, direct memory access. And the in-memory transit architecture is based on RDMA, remote direct memory access, which has proved to be very... So basically, we have built all the pieces that are useful today. So basically, this is a conclusion. Yeah, I can say a few words about what's going on right now. So it's an ambitious project. At Inria, we are very interested in it because it has been, well, we have real applications that need it. And what we like is this idea of providing service APIs to ease reuse in other projects. And for example, we have a project at Inria that I'm
leading called Life Science Data Services. So these are, well, very much like Amazon Web Services, you know. You have all kinds of rich services that can work in various combinations because they have very well-defined APIs. And we have similar objectives, except that it's much more general. And so a bit ambitious. In fact, it will be the basis for a new Inria project. Okay, so that's, well, basically this is already described, but that's the state of that project. There will be a more detailed presentation on the DG ensemble method on Thursday, I think, by Fabio Porto, LNCC, for those of you. So I thought it would be a good way to introduce. Thank you. So since I have an expert in machine learning, so what do you think about this idea? I'm asking questions. You know, I'm retired. Oh, formally, I'm retired now, so I really don't. But what do you think of this idea of, you know, instead of, for example, in PlantNet, we have single model for all the plants. And, but you may think that, well, the plants in Brazil, Amazonia, which are not well known, are quite different than those in Europe. So what do you think of having more specialized models, which you can, maybe you want to reuse the model from Brazil in Africa, because maybe it's similar. I've lived in Africa, so I see a lot of similarity, not just people, but the trees, you know. In Europe, they are not that big. So what do you think about this idea of model composition? It works. Which is what's happening with PlantNet. You know that. Exactly. There are pros and cons. And in fact, related to your talk this morning, I think it would be great to use some knowledge, have concepts that can guide decisions. And we could say, well, although this plant is rare, well, we really want to pay attention to that plant because it will, well, it's the plant that cures. And concept. Very good. So you're giving me, because the next step is that Fabio Porto will visit my. Okay. working exactly on this with PlantNet. So arguments. Well, your turn. Maybe a few questions because but I'm taking advantage. I'm here, so I want to go back home with something. I think it's time for coffee. Well, we can discuss some coffee. That's the, we'll use a session chair. So, okay, so coffee break. Okay, so we have to follow you. So do you bring a flag? No, you. But remember, there's Innova, but there's also something else. It's with you. Okay, yeah, because I'm going. Okay.
Good.